Welcome to the untamed depths, where silence reigns, shadows stretch forever, and mystery clings to every drop of water. Tonight, we journey beneath the waves, into a world that covers more than 70% of our planet, yet remains more unknown than the surface of the moon. The oceans are both cradle and graveyard, home to life in its strangest forms, and keeper of secrets buried in darkness. For thousands of years, humanity has gazed at the sea with awe and fear. Sailors spoke of monsters rising from the waves, of ghost ships drifting with no crew, of whirlpools that swallowed entire fleets. But as our ships and science pushed further, we discovered that the truth was stranger still. The ocean's depths are alive with alien beauty. Glowing fish, boiling vents, and landscapes no human eye had seen until recent decades. Down there, sunlight dies quickly. Within a few hundred meters, light vanishes entirely. And yet, life thrives. Twisted, adapted, almost supernatural. Creatures with glassy bodies, teeth like daggers, and lanterns glowing in eternal night swim in realms we barely understand. Tonight, let us explore these forgotten worlds. From trenches deeper than Mount Everest is tall, to ancient wrecks resting silently in the sand, we will wander through the unknown, guided only by whispers of what science and legend have revealed. The oceans hold stories waiting to be uncovered. So settle in, let your thoughts drift like currents, and together, let's descend into the mysteries hiding beneath Earth's oceans. The ocean begins where the land bows out, an endless swell of shifting light and color, a boundary between firm earth and liquid mystery. You stand at the water's edge as dawn's first rays fold over the waves. The breeze carries the scent of salt and distant depths. In that moment, you feel both the world's edge and its beginning. Beyond your reach, beneath that shimmering surface, lies a realm so vast it defies comprehension. It is a realm of silence and shadow, a place where sunlight fades and the familiar world gives way to the untamed depths. More than 70% of Earth's surface is draped in ocean. 200 million cubic miles of water swirl in currents that cradle plankton and whale alike. Yet even with satellites mapping every mountain on land, less than 20% of the seafloor has been charted in detail. Most of it remains an unlit frontier where pressure crushes steel and darkness reigns. In that darkness, entire ecosystems flourish without sunlight. In that immense dark, countless species have adapted in ways we have scarcely begun to imagine. Mapping these depths would take lifetimes, if not centuries, but the urge to explore calls to us as surely as the tide. As you breathe in the salt-laden air, imagine descending through the ocean's layers. From the sunlit euphotic zone, you slip into the twilight of the mesopelagic, where faint glimmers mark the outlines of drifting fish. Deeper still lies the bathypelagic abyss, a place of near-total darkness. In these depths, creatures with bulbous eyes, transparent bodies, and glowing lures stalk the void. But you have not yet reached the greatest depths. Below you stretches the Hadal Zone trenches deeper than Everest's peak is tall, where pressure is a crushing 10,000 pounds per square inch and temperatures hover near freezing. In those trenches lie canyons, hills, and valleys as varied as any on land, all waiting to be seen. From the earliest ages, seafarers have gazed across calm seas and storm-scoured waves, spinning tales of sea monsters and lost cities. Mariners spoke of whirlpools that dragged ships to watery graves and phosphorescent waters alive with ghostly lights. In the age of sail, explorers charted coastlines but remained blind to the depths beneath. Whalers followed migratory prey but never glimpsed the world below. It was not until the advent of diving bells and rudimentary submersibles that tiny windows of the deep opened to human eyes. Even then, every descent revealed marvels that challenged our sense of possibility. Today, we weave our understanding of the seafloor with sonar pulses and satellite altimetry. Ships tow sensors that ping the bottom, painting rough contours in blue-green grids. But between those lines stretched the unknown. Only a handful of deep-sea trenches have been visited by submersibles. The rest remain speculative shadows in datasets. The deep ocean resists familiarity. It demands specialized vessels, able to withstand the cold and pressure, vehicles guided by pilots, or robots maneuvered from distant decks. Exploration moves at the pace of caution, each dive a careful negotiation with forces beyond our mastery. Descending, you cross the boundary into the ocean's middle depths. The walls of water around you darken to ink, and only your lights carve a slender cone of visibility. Here, ridges taller than Everest rise from the abyssal plain. Mule-sized fish drift in silvery schools, and tufts of life cling to every crevice. You pass over hydrothermal vents fissures in Earth's crust that spew superheated water laden with minerals. There, ecosystems thrive on chemosynthesis rather than photosynthesis. Giant tube worms, blind shrimp, and bacteria, dancing at 400 degrees Celsius, live in symbiosis, each motion part of an ancient alien choreography. Bioluminescence sparkles around you like lanterns in a cathedral. Small jellyfish pulse with neon rings. Squid with trailing filaments glide past. Tiny crustaceans drift like living snowflakes in the current. Predators flash glowing lures to attract prey into snapping jaws. These light shows form a secret language of the sea, signals for mating, warnings of danger, beacons for feeding opportunities. In this world, light is a commodity more precious than gold, and every organism has evolved to either hide its glow or wield it as a weapon. Despite the ocean's size, we know only a fraction of its inhabitants. Scientists estimate that 90% of marine species remain undescribed. When researchers trawl the depths or peer through submersible windows, they turn up creatures so strange they momentarily unmoor our sense of possibility. Ghostly anglerfish with teeth like razors, shrimp with spindly limbs and spines, forms that burrow through mud like living needles. They defy terrestrial comparison. In every sample brought to the surface, genetic analysis reveals DNA sequences with no match in any database, hinting at lineages lost to time and silence. Hidden among the cold, dark waters are methane seeps, places where gas bubbles rise from sediments, feeding bacterial mats and communities of clams and mussels that splay their gills in chemical feasts. Nearby, brine pools lie like black lakes on the seafloor, salt concentrations 10 times that of seawater. They shimmer with a mirror-like surface, bordered by haliclines that sting if touched. Communities of bacteria color their edges red and orange, consuming sulfur compounds in endless microcosmic cycles. These habitats operate by rules utterly different from coastal ecosystems, yet they hold clues to life's resilience in extremes. Exploring these zones demands technology that feels borrowed from science fiction. Human-occupied submersibles with sphere-like cabins descend tethered by cables, while remote-operated vehicles, ROVs, roam untethered, sending back live video and collecting samples with articulated arms. Autonomous gliders drift on programmed paths, measuring temperature, salinity, and chemical signatures. Bathymetric drones map hidden ridges. Acoustic monitors listen for the songs of whales and the clicks of dolphins. Each new tool extends our senses, letting us touch the unknown without leaving the surface. Beneath it all lies the tectonic engine that shapes our planet. Mid-ocean ridges, mountains of basalt that bisect ocean spring from rising magma as continents drift apart. Subduction zones, where one plate dives under another, forge deep trenches and fuel arc-shaped chains of volcanic islands. Earthquakes ripple through the undersea landscape, triggering tsunamis that reshape coastlines. Even as we explore, we are reminded that the ocean floor is not static, but an active canvas, remade by forces powerful enough to reshape continents over geologic time. The ocean's vastness also holds the imprint of human impact. Plastic fragments swirl in gyre spirals of debris, thousands of miles across. Synthetic chemicals settle in sediments, and move through the food web, appearing in fish and seabirds. Underwater noise from shipping and seismic surveys disrupts marine mammals' communication. Overfishing has hollowed out coral reefs and lanternfish populations, once so abundant they fueled entire Arctic ecosystems. In the abyssal plains, deep-sea mining looms, a prospect that could extract metals from nodules, but risks destroying habitats never before seen by human eyes. Yet with all these challenges, the ocean offers hope. Marine protected areas conserve coral reefs and kelp forests, allowing fish populations to recover and carbon to be sequestered in seagrass beds. Innovative technologies harvest energy from waves and currents, promising clean power without combustion. Acoustic monitoring helps enforce fishing regulations, protecting endangered species. By combining ancient wisdom, such as Polynesian navigational knowledge, with cutting-edge science, coastal communities steward their waters more sustainably. As night falls over the water, let your mind drift with the tides. Picture the endless darkness beneath your boat, a realm of stone spires and chimneys that vent Earth's heat into cold seas. Picture creatures glimmering like constellations in a midnight sky of water. Picture the slow march of robotic explorers, tracing contours unseen by any eye before. Each journey into the deep teaches us humility before the planet's vastness and ingenuity in unraveling its secrets. The ocean hides its mysteries behind layers of water, pressure, and lightless miles. Yet every dive, every sonar ping, every genetic test brings us closer to understanding. The ocean is both cradle and crucible, a place where life persists in forms beyond our expectation. It reminds us that, despite our technology, we remain explorers at the threshold of the unknown. In its depths lie the beginnings of life, the engines of climate, and the promise of discovery that will shape our future. So let the rising tide of curiosity carry you into sleep. Drift on dreams of undersea cathedrals, where stone pillars of basalt hold colonies of anemones, and hydrothermal vents spew clouds of iron-hued plumes. Rest in the knowledge that, though the ocean covers most of our planet, it remains a frontier of wonder. In its untamed depths lie challenges and treasures, threats and promises. And as you drift into the quiet of night, remember, the greatest mysteries may yet be the ones below the waves, waiting patiently for the moment when we finally learn to listen. You glide beneath the surface until the last sliver of sunlight filters through the water above. Here, at depths between 200 and 1,000 meters, begins the ocean's twilight zone, a place neither bright nor utterly dark, but awash in a hushed half-light that feels suspended between worlds. Every ray of sun here is diffused into a muted blue-gray glow, enough to cast faint shadows, but never enough to banish the night. In this in-between realm, the water presses in around you, each meter adding weight until a room-sized chamber of steel and glass barely stands against the pressure. Your submersible's lights sweep across a landscape that seems carved from shadow, rolling hills of mud, canyons veiled in cloudy currents, and ghostly outlines of ridges that stretch toward unseen horizons. The silence is profound, broken only by the soft hum of life creatures drifting through an ocean cathedral lit by their own bodies. As you drift forward, luminescent flickers begin to appear. Tiny plankton glow like flecks of starlight in a liquid night sky, pulsing in and out of view. Each flicker is a signal and invitation, or a warning part of a hidden language spoken only here, where sunlight fails. You see cone jellies, their cilia refracting blue and green bands of light as they ripple in delicate waves. You mark the outline of small shrimp, their antennae trailing phosphorescent sparkles like U-shaped lanterns guiding them through the gloom. Further on, you encounter the first of the zone's most famous residents, the lanternfish. They hover motionless, bodies slender as blades, eyes large and unblinking. Along their undersides, rows of tiny photophores glow in soft, rhythmic patterns counter-illumination that erases their silhouette when predators below search the surface for prey outlined against the dim light. From above, they would appear invisible, as though they vanished into the water itself. The submersible ice lights reveal bristlemouth fish no larger than your forearm, yet among the most abundant vertebrates on the planet, numbering in the trillions. Their bellies glow with subtle luminescence, each flicker a living star. They flank you in drifting shoals, moving with slow choreography, part of a nightly ballet that pulses through the mesopelagic depths. You pause among ghostly forms, squid no longer than your hand, their eyes barely visible orbs that catch your light and reflect back an eerie green. Their arms, some tipped with photophores, dangle like soft fringe. Here and there, the silhouette of a vampire squid drifts by, webbed arms drawn close, dark body glowing at the tips with faint red bioluminescence. It patrols the inky currents, a creature as ancient as the zone itself, surviving on strands of marine snow detritus drifting down from sunlit waters above. Below you, the temperature has dropped to just above 4 degrees Celsius. Each breath from your sub tingles with the cold. The zone's narrow thermal range shapes every body here. No sudden freezes, no sudden warms, just a steady chill that feels almost comforting in its constancy. Yet within that chill life adapts in remarkable ways. Mouths unhinged to swallow oversized, prey stomachs that stretch to hold a snack worth the energy of the long drift, and transparent bodies that render their hosts nearly invisible when predators search by shape rather than by light. You witness the daily migration in progress. Lanternfish and shrimp begin a slow ascent, rising toward the faint glow near 200 meters. Every dusk, they swim upward to feed on plankton that flourish just below the surface. By dawn, they retreat to the dark depths to digest and hide. This movement, billions of creatures rising and falling each night, is the largest migration on Earth by biomass. It shuttles carbon from surface waters to the abyss, a living conveyor belt in the ocean's rhythm. As you follow this upward drift, the glow above brightens just a little. Hints of sky filter through water, and you glimpse the underside of waves curling 200 meters overhead. You watch ghostly silhouettes cross the faint lens of light, squid with iridescent rings of photophores, fish with spines tipped in luminescent spots, and cephalopods that open their soft bodies to reveal swirling starfields within. Yet you do not stay at the shallower rim. Turning your lights back inward, you descend again into the cheeks of shadow. You note clusters of ribbed gastropods clinging to small outcroppings, and clusters of brittle stars woven together like living carpets. In the gaps, small crabs scuttle past, their dark shells dull, but for a few glowing dot's-eye spots or warnings, nobody knows. The zone has rocky outcrops, sometimes reveal unexpected wonders. Cold water, coral gardens that decorate boulders in white and pink branching whorls. These corals grow without sunlight, feeding on drifting particles, their polyps extended like tiny hydras in a secret garden. Sponges anchor themselves to ledges, bright blue or deep red, filtering water from microbes invisible to all but molecular cameras. Sound, too, plays its quiet symphony here. The clicking calls of deep-diving sperm whales echo through the water, heard faintly but unmistakably in your hydrophone. The taps of a deep-sea fish, possibly a rattling courtship call, rattle your instruments. Even the hum of your own vehicle becomes part of the orchestra, blending with distant seismic rumbles, evidence of shifting tectonic plates, a reminder that this world lies atop Earth's restless interior. You slow your pace to let the zone reveal its hidden patterns. You notice thin streams of marine snow drifting downward, particles of detritus, fecal pellets, and organic decay life's leftovers feeding the creatures below. You see clusters of tiny eggs and larvae, ghostly forms that hint at life yet to grow, at generations perpetuating the twilight's twilight. In this half-lit world, nothing is wasted. Each ripple of bioluminescence is a conversation. I am here. Stay away. Come closer. Each creature carries its own light source, calibrated to its needs. Bioluminescence evolves independently in countless lineages, some using bacterial symbionts, others powering chemical reactions within their own bodies. These adaptations speak of eons spent perfecting life beneath a sun that never fully arrives. And still, so much remains unseen. Sonar surveys sketch only rough outlines of valleys and ridges. Cameras glimpse a handful of species. Genetic analysis of water samples teems with unknown DNA, suggesting thousands of species awaiting discovery. Every hour spent here adds another puzzle piece, but the full picture lies deep in black water beyond submersible reach. Above you, faint solar photons slip away. Below you, the abyss yawns without end. Between them, the twilight zone holds secrets of adaptation, migration, and survival under conditions we can only imagine. It is a realm of extremes pressure packing water molecules into unseen density, temperature frozen near the limit of life, and light so rare that it becomes the most precious resource. As you prepare to ascend, you cast one last glance at the shifting shadows and living lights. Remember the fleeting dance of lanternfish, the silent drift of cone jellies, the enduring glow of tubeworm colonies around unseen vents. Carry with you the hush of this place, the knowledge that life persists in the quietest corners, that evolution finds a way even where sunlight fails. And when your craft finally crosses back into the brilliance of the sunlit world, let the memory of that dim realm stay with you, a reminder of how little we know and how vast the ocean's night remains. In the twilight zone, every flicker is an invitation to wonder, an invitation to return, to explore, and to listen for the stories written in bioluminescent ink beneath the waves. Beneath the waning light of the mesopelagic zone lies one of Earth's final frontiers, the abyssal plains. These are vast stretches of almost featureless seafloor, lying between 3,000 and 6,000 meters below the surface, covering more than half of our planet's area. From a submersible's viewport, they appear as endless gray carpets, broken only by the occasional rise of a submerged hill or the track of a migrating scavenger. In this realm, the familiar laws of landscape, mountains, valleys, forests give way to a horizon so flat it seems unnatural. Here, as you drift slowly, every sense sharpens to detect the faintest motion or the faintest glow. The formation of these plains is a story etched in plate tectonics and sediment. At mid-ocean ridges, molten basalt wells up and hardens into new crust that slowly slides away. Over millions of years, layers of fine clay, silt, and the microscopic remains of plankton settle atop this basaltic foundation, smoothing out its uneven contours. Turbidity currents underwater, avalanches of sediment rush down continental slopes, carrying coarser grains into deeper basins, where they form graded layers often only millimeters thick. This relentless blanketing has created some of the planet's flattest surfaces, sediment accumulations up to a kilometer thick, burying any underlying relief. Despite their apparent monotony, abyssal plains host subtle topographic features. Sparse volcanic seamounts, once active undersea volcanoes, protrude as lonely cones. Fracture zones from tectonic stresses carve faint scars across the clay. Scattered fields of manganese nodules, each the size of a golf ball or larger, lie half buried in sediment. These nodules accumulate metals like manganese, iron, nickel, cobalt, and copper over millions of years, offering clues to both geological processes and potential human resource exploitation. Physical conditions on the abyssal plains are extreme and unyielding. At depths around 4,000 meters, pressures exceed 400 atmospheres, over 400 times what we experience at sea level, and temperatures hover between 1 and 4 degrees Celsius. Sunlight never penetrates this far, and the only light comes from bioluminescent creatures. Currents here are slow, measured in centimeters per second, yet they shape the seafloor by redistributing sediment and delivering detritus from above. In such a place, life must adapt both to crushing weight and to frigid, stagnant water. Sedimentation rates on abyssal plains are among the slowest on Earth, averaging a few millimeters per 1,000 years. Between pulses of rapid deposition by turbidity currents lie vast expanses where red clay accumulates at scant fractions of a millimeter per year. This thin veneer of mud blankets the basaltic crust, preserving the record of ancient climates, volcanic eruptions, and shifting ocean currents. Each centimeter of sediment corresponds to centuries or even millennia of environmental history. Oxygen is a precious commodity in these lightless depths. Dissolved oxygen arrives through thermaline circulation, sinking cold polar waters that carry atmospheric oxygen deep into the ocean basin. Yet because metabolic demand in the abyssal zone is low, oxygen concentrations remain just above the threshold needed to support aerobic life. Organisms here often exhibit slow metabolisms, minimizing their oxygen requirements in an environment where every molecule counts. Food for abyssal communities falls from sunlit waters above in the form of marine snow, drifting particles of dead plankton, fecal pellets, mucus aggregates, and other organic detritus. This rain of carbon sustains a food web far removed from photosynthesis. Some organisms capture and consume each particle, while others specialize in scavenging occasional large falls, such as the carcass of a whale known as whale falls. Over time, this trickle of energy fuels a surprising diversity of life on the seemingly barren plains. Microbial life dominates the sediments. Bacteria and archaea metabolize organic compounds, breaking down complex molecules into dissolved nutrients. These microbes form the foundation of abyssal ecosystems, processing detritus and regenerating dissolved inorganic compounds that feed higher trophic levels. In intensely studied sediment cores, scientists find that microbial biomass may exceed that of all multicellular life combined, highlighting the abyssal plains as a critical component of global biogeochemical cycles. Deposit-feeding invertebrates are among the most conspicuous animals on the abyssal plains. Sea cucumbers, a type of holothurian echinoderm, glide across the mud, ingesting sediment and extracting organic matter. Tiny polychaete worms, some no longer than a pencil lead, burrow and tunnel through the soft clay, aerating the seafloor and facilitating nutrient exchange. Their undulating movements leave faint trails that are later smoothed over by currents, testifying to a constant, though quiet, bustle of activity. Crustaceans also thrive here in specialized forms. Amphipods, slender, shrimp-like scavengers, swarm carcasses and detritus piles, their bodies tough enough to withstand pressure. Isopods, relatives of pillbugs, creep over nodules and clumps of sediment, feeding on microbial mats. Squat lobsters hang beneath overhangs of buried relief, capturing suspended particles or preying on smaller invertebrates. These crustaceans often exhibit slow growth rates and long lifespans, strategies that match the low-energy environment. Echinoderms beyond sea cucumbers flourish as well. Brittle stars, with their long, flexible arms, form carpets that sway in invisible currents, capturing detrital particles. Some brittle stars extend their arms into filaments to feed, while others wrap food toward their mouths. Sea stars, less common but striking when encountered, spread their broad arms to trap prey. The low temperatures and stable conditions allow echinoderms to grow slowly but attain sizes rivaling those in shallower waters. A small but vital community of fish inhabits the abyssal plains. Cusk eels, some with translucent skin, swim near the bottom, feeding on invertebrates. Snailfish, a group with gelatinous bodies and reduced bone. Structures sparkle with internal luminescent patches that may help them attract prey or communicate. These fish often have large mouths and extendable stomachs, adaptations for the unpredictable feast of marine snow and occasional carrion. Their slow swimming conserves energy, matching the sparse food supply. Bioluminescence in the abyssal plains is more subdued than in the twilight zone, yet it persists. Some fish and invertebrates carry photophores, light-producing organs, used for camouflage, attraction, or warning. A sudden flash of blue or green light can startle predators or signal danger. Other organisms emit a constant glow, illuminating footprints in the sediment for others to follow to food. Bioluminescence here underscores that even in utter darkness, life still communicates in light. Although hydrothermal vents lie beyond the typical abyssal depth, occasional cold seeps and methane escapes dot the plains. These sources of chemical energy foster localized oases of life. Clams and mussels cluster around seep sites, harboring symbiotic bacteria that oxidize methane or hydrogen sulfide. The contrast between nutrient-poor sediments and these bubbling seeps reveals the dynamic interplay of geology and biology that shapes deep-sea ecosystems. Exploring the abyssal plains demands specialized technology. Human-occupied vehicles, like Alvin fitted with thick acrylic viewing ports, descend tethered by miles of cable. ROVs, remotely operated from surface ships, carry high-resolution cameras and manipulator arms to collect samples. Autonomous underwater vehicles, UVs map large swaths of seafloor with sonar and optical imaging, revealing kilometer-scale patterns of sediment and scouring events. Each mission requires meticulous planning to protect fragile equipment from implosion under extreme pressure. Mapping these remote plains relies on a combination of ship-towed multi-beam sonar and satellite altimetry. Multi-beam systems send swaths of sound pulses to the bottom, generating detailed bathymetry at resolutions down to tens of meters. Satellite measurements of sea surface heights infer seafloor topography based on gravitational anomalies. Yet even with these tools, only a fraction of the abyssal expanses boast high-resolution charts. Far more remains in low-detail grids or unexplored shadow areas. Sampling the abyss involves gravity cores and box cores that capture sediment columns, dredges that scrape nodules and rocks, and sediment traps moored above the seafloor. Each core reveals a layered history of sediment deposition, climate change, and even volcanic ash falls. Dredging may unearth sponge gardens, exposed bedrock, or bits of coral, offering direct evidence of benthic communities. But these methods disturb the fragile seafloor, so scientists balance data collection with conservation. Despite centuries of oceanographic research, the abyssal plains harbor unknown diversity. Estimates suggest that up to 90% of deep-sea species remain undescribed. Genetic surveys of environmental DNA, recovered from sediments reveal lineages with no known relatives, hinting at undiscovered phyla and families. Each new expedition adds novel species tiny gastropods that filter detritus through feather-like gills, worms with branching bodies that resemble living lace, crustaceans bearing strange mineralized armor. Human impacts now reach these remote depths. Interest in deep-sea mining for manganese nodules threatens to turn pristine plains into barren fields dredged clean of nodules and disrupted for decades, possibly longer. Noise pollution from seismic surveys for oil and gas can interfere with the communication of deep-diving whales, whose songs may carry hundreds of kilometers. Microplastics have been found in sediments and gut tracts of abyssal organisms, evidence that no place on Earth remains untouched by human activity. Climate change and ocean acidification also exert pressure on abyssal ecosystems. Warming surface waters alter stratification and reduce nutrient flux to the deep. Acidified water dissolves calcium carbonate shells and skeletons, threatening corals, foraminifera, and other calcifying organisms even thousands of meters deep. As the ocean absorbs anthropogenic CO, deep-sea pH may decline, eroding the habitats that cold water corals and bivalves depend on for shelter and breeding. Conservation efforts for abyssal plains remain nascent. International agreements under the United Nations framework, Convention on Climate Change, and the Convention on Biological Diversity propose marine protected areas in high seas regions. Scientists advocate for hope spots that safeguard representative habitats and biodiversity hotspots. Effective stewardship requires expanded research, careful environmental impact assessments, and regulations that balance resource extraction with ecosystem preservation. But beyond exploitation and protection, the abyssal plains hold lessons in resilience. Life here persists on the merest trickle of energy, adapting to extreme pressure, cold, and darkness. These ecosystems demonstrate the power of slow, steady functioning microbial recycling, deposit feeding, detritus consumption, and remind us that survival in the face of scarcity depends on cooperation and efficiency rather than abundance. In the quiet vastness of the abyssal plains, there is a hum of continuity. Sediment accumulates slowly. Microbial metabolisms grind on without pause. Animals drift and crawl, leaving ephemeral footprints on an otherwise static surface. Here, time feels different, measured in centuries per centimeter of sediment, in lifespans that can span decades or more in creatures adapted to minimal energy budgets. As you prepare to ascend, let your mind linger on the plains below. Recall the gentle glow of bioluminescence against a steel blue backdrop, the sight of coral gardens blooming in perpetual darkness, and the faint hum of life processing the planet's greatest carbon sink. In that memory lies both humility and wonder. Humility before the scale of the unseen world, and wonder that life flourishes even in the most extreme places. When your vessel finally breaks through the boundary into the mesopelagic, allow yourself a moment of reflection. The abyssal plains remain out of sight, yet ever present, an essential, living part of Earth's system. In the days ahead, let the knowledge of their quiet resilience guide our choices on land and sea. For in preserving these flat, featureless expanses, we safeguard the deepest chapters of our planet's story and honor the strange, tenacious life that clings to survival in the untamed depths. You descend through the water column until the last glimmers of daylight vanish overhead, leaving you in a realm of perpetual night. The pressure presses in around you, hundreds of atmospheres weighing on every square inch of hull, and the temperature hovers just above freezing. Yet here, along the seams of Earth's crust, emerges a scalding breath from the planet's fiery heart. This is the domain of hydrothermal vents, fissures in the seabed that belch superheated, mineral-rich fluids into the abyss. As your submersible glides closer, you spot the first plumed towers of obsidian black smoke rising from the sediment like otherworldly chimneys. These black smokers hiss at nearly 400 degrees Celsius, hot enough to melt many metals. Yet the surrounding seawater, at just 2 degrees Celsius, envelops them in a ring of boiling mist. Mineral-laden water, enriched with iron, sulfur, and manganese, plumes upward and solidifies into rocky tubes chimneys that can grow as tall as an 18-story building in just a few years. The sight is startling. Pillars of black metal glowing faintly red in your lights, punctuated by tongues of shimmering fluid. Around them, the seabed is stained orange and white by iron oxide crusts and shimmering sulfur deposits. The water tastes faintly acidic, and every sample you collect feels gritty with microscopic ore particles. This is a place hostile to most life, yet life here not only survives, but flourishes. Clinging to the vent chimneys, you see the first inhabitants, giant tube worms standing like silent sentinels. Their plump red plumes emerge from white, chitinous tube soft bodies invisible to the eye. Inside each worm, symbiotic bacteria convert toxic hydrogen sulfide from the vent fluids into organic carbon, nourishing their hosts in a process called chemosynthesis. Without sunlight or green plants, these worms and their bacterial partners form the foundation of a rich food web. All around the chimneys, clusters of clams and mussels fan out in wreaths of shells. Their gills glow faintly with the same red sulfur-eating bacteria, sealed inside to feed the host. In between, you glimpse shrimp-like creatures with milky white bodies and bright white spots of vent shrimp, that wave their feathery arms to waft in chemical-rich water, harvesting nourishment from the plume itself. Amid this alien garden, predatory crabs scuttle across the rocky surfaces. Their hardened shells bear the scars of heat and acid, yet they prosper, snapping up small invertebrates and scavenging bacterial gnats. Snails with shell-like flutes cling to ledges, grazing on microbial films, while ghostly fish hunt in the dim margins, their transparent bodies nearly invisible against the black rock. In the distance, smaller white smokers exhale cooler plumes tinted pale by dissolved barium and calcium. Their chimneys, more fragile and shorter-lived, host different communities. Squat lobsters shelter beneath ledges, and elegant anemones wave tentacles in the current. The fuzz of polychaete worms collects on every surface, forming feathery carpets that sway like underwater meadows. Occasionally, you venture beyond the smokers to see cold seeps, where methane and light hydrocarbons seep from the seabed. Here, bacterial mats bloom in yellow and orange patches, feeding communities of tube-worms, clams, and mussels similar to those at the smokers, but adapted to lower temperatures and different chemicals. Streams of bubbles rise from the mud, shimmering in your spotlight like a rain of tiny silver beads. Each vent field is surrounded by dark sediment that glows faintly with bioluminescent drift. Tiny crustaceans flash in coordinated pulses, signaling to mates and warding off predators. Comb jellies ripple in slow, rainbow bands as their ciliary plates refract your lights. This living glow weaves through the gloom, a secret language of survival written in fleeting points of light. Despite the toxicity of vent fluids rich in heavy metals and sulfides, life thrives by harnessing chemistry rather than sunlight. The discovery of these ecosystems in 1977 transformed our understanding of life's possibilities, suggesting that anywhere liquid water meets energy from Earth's interior, biology can flourish. Scientists now think similar vents on icy moons, like Europa and Enceladus, might harbor life far from our sun. Below the smoking chimneys, the seafloor slopes gently into darkness. Here, you find the remains of whale falls, carcasses that have sunk and transformed into oases of nourishment. Bone-eating worms tunnel into the marrow, while sharks and deep-sea fish circle, feasting on scraps. Over years, each whale fall passes through stages. Mobile scavengers strip flesh, then sulfophilic bacteria convert lipids in the bones into energy, supporting clams, mussels, and the same chemosynthetic processes found at vents. Every dive here reveals new creatures' brittle stars, tinted red with hemoglobin, fish with massive, unblinking eyes, and snails bearing strange shells that fuse bacterial filaments into living armor. Many carry plastic fragments in their guts, a silent reminder that no corner of the ocean is untouched by human reach. The vent fields shift over time. Chimneys collapse under their own weight, or when mineral deposits clog the conduits. New vents ignite nearby as tectonic plates move and magma intrudes. Entire communities migrate, larvae drifting on currents to colonize fresh vents. This cycle of birth and decay echoes volcanic islands on land, reminding us that life persists amid change, following the pulse of Earth's interior. To study these systems, researchers deploy remotely operated vehicles with robotic arms to pluck worms from chimneys and scoop sediment into sample jars. Temperature probes map the thermal gradient, revealing zones from scalding cores to cooler fringes. Water samplers capture fluid chemistry, pH, sulfide concentration, metal content, unlocking the alchemy that fuels chemosynthetic life. Cameras record high-definition video, capturing the slow ballet of creatures that thrive in conditions lethal to us. Back on the surface, scientists analyze each sample, isolating bacteria that fix carbon without sunlight. They study the enzymes that allow proteins to fold under high pressure and temperature, enzymes that may hold keys to industrial chemistry and medical advances. They map the genomes of vent organisms, seeking genes that confer resistance to toxins and harness energy in novel ways. Hydrothermal vents remind us that life on Earth is more versatile than we once believed. They offer glimpses of early Earth, when oceans teemed with chemical energy rather than sunlight, and hint at the resilience of life on worlds beyond our own. They challenge our definitions of habitability and broaden our search for life in the universe. As you prepare to ascend, you take one last look at the glowing chimneys and their bustling communities. The contrast is striking. Plumes of toxic black smoke against a backdrop of organisms shaped by chemistry. Not light. Creatures that thrive on molecules so poisonous to us that they would burn our lungs. A garden of life where we once thought only death awaited. Rising slowly through the layers of water, you carry with you the memory of this alien world of scalding vents in fragile ecosystems, of bacterial mats carpeting rocky chimneys, of tube worms and clams clustered like coral in darkness. You return to sunlight, surface air, and warmer temperatures changed by what you have seen. Life as astonishing ability to find a foothold anywhere energy flows, even in the most hostile corners of our own planet. In the silent depths where no sunlight reaches, the ocean becomes a cathedral of darkness. In that vast, inky realm, life still finds a way to sparkle. Here, in the hidden corners of the sea, creatures carry their own stars, turning chemical reactions into living lanterns. As you settle deeper into calm breathing and drifting thought, imagine a world lit not by the sun or moon, but by the creatures themselves, their bodies glowing with soft pulses of blue, green, and sometimes rare red light. This is the realm of bioluminescence, where light becomes tool, lure, and shield in equal measure. Bioluminescence begins with a simple chemistry. A molecule called luciferin meets an enzyme called luciferase, sparking a reaction that releases energy as cold light without heat. In some creatures, this reaction unfolds in specialized organs called photophores. In others, it is the work of symbiotic bacteria housed in tiny chambers beneath transparent skin. The result is a living glow that can be switched on and off at will, a whisper of light in the silent dark. Picture yourself floating in a slender submersible, your lights dim to avoid startling the residents of this shadowed realm. Around you drift the first signs of life's faint glimmer. Tiny crustaceans, no larger than your fingertip, wheel through the water in wisps of blue krill and copepods dancing in a cloud of living sparkles. They pulse in unison, a swirling congregation of living fireflies, each glow a heartbeat in a chorus of motion. Draw your gaze deeper into the gloom, and you'll see comb jellies, kinetophores whose translucent bodies ripple with rainbow bands as their ciliary comb rows catch your light. Though their own luminescence is subtle, it flickers as they drift, refracting bioluminescent flashes into fleeting rainbows. In the hush of the twilight zone, their gentle movements enchant like drifting lanterns in a midnight sky. But not all bioluminescence is so ethereal. In the deeper reaches, anglerfish carry terror in their lights. Picture a rounded body, jaws lined with backward curving teeth, skin stretched taut over bulbous eyes. From its forehead hangs a slender rod tipped with a glowing esca, a lure of bacteria-fed light. In the darkness, that single point of brightness becomes impossible to resist. Curious fish drift close, drawn to the promise of prey, only to be engulfed by the angler's cavernous mouth. In that instant, bioluminescence becomes a deadly weapon, a trap laid in living light. Nearby lurks the stoplight loosejaw, a fish whose jaw swings wide to reveal an orb of red light hidden beneath its body. In depths beyond the reach of blue wavelengths, this red illumination is invisible to most prey. The loosejaw switches on its beacon, spotting creatures by their silhouettes against the feeble glow, and snaps shut with a speed born of centuries of adaptation. In this realm, the color of your glow can be the difference between dinner and oblivion. Not all glowing hunters use lures. The dragonfishes patrol the midwater in stealth, lined with rows of greenish photophores along their undersides. They use counter-illumination matching the dim light from above to erase their shadow, to become ghosts against the faint glow of the twilight. From below, predators cannot distinguish them from light filtering downward, and from above, prey see only a patch of open water. Among the soft sediments of the abyssal plains, bioluminescent forms paint the mud with fleeting sparks. Ostracods' tiny seed shrimps flit in and out of view, their bodies flickering in patterns that signal everything from courtship to escape. When threatened, they burst into a series of rapid flashes, confusing predators long enough to dart away in the dark. Imagine now a grove of deep-sea anemones, their tentacles tipped with photophores that glow in delicate blue-green. They wave in invisible currents, luring small fish and crustaceans into their grasp. Each stinging cell, hidden in that glowing fringe, drags prey toward the anemone's mouth, a gentle trap bright as a neon sign in a desert of black. High up near 200 meters, lanternfish rise in their nightly migration, shoals of tiny beacons drifting toward surface waters. Their photophores glow to match the faint daylight, keeping them hidden from shifting silhouettes below. They feed on zooplankton under the moonlit surface, then retreat to depth before dawn, carrying carbon and life into the abyss, a living link in a global cycle of light and dark. In the shallows, closer to the sunlit world, other bioluminescent wonders await. Imagine a squid no larger than your palm, its body sprinkled with photophores that pulse like breathing stars. When threatened, it can release a cloud of glowing ink and aurora of chemical light, disorienting predators and vanishing into the night. This flash of brilliance buys it time, a living smokescreen in a sea of gloom. On coral reefs, small flashlight fish peer from crevices, their eyes rimmed with pockets of glowing bacteria. They blink on and off, silent signals to mates or warnings to intruders, then slip back into the shadows. In their flicker, they hold both private secrets and communal stories, a hidden dialogue in living light. Farther north, in cold-tempered waters, comb jellies and deep-water shrimp glow in quiet bioluminescent pulses. Each species adapts its glow for hunting or hiding. Some wave flashes to mimic moonlight on waves. Others emit sudden streaks to startle and stun small fish. In every case, light becomes a tool painted in living strokes across the water column. Even humans find use in these glowworms of the deep. Scientists harvest luciferase enzymes for medical research. In laboratory assays, a glimmer reveals the presence of a single molecule of D-NIR protein. In medicine, bioluminescence helps track disease progression in living cells. In industry, it finds use in environmental monitoring. If bacteria glow in polluted waters, they signal danger far sooner than chemical tests can detect. Back in the deep, a gentle hush returns as your lights dim to rest. You drift among the living stars, the hush broken only by the occasional pulse of a photophore or the slow dance of lanternfish shoals. In this silent ballet, every shift of light tells a story of hunger, of fear, of hidden lives that thrive in the blackness. Let your thoughts float among these glowing forms, each flicker a lullaby. Imagine the anglerfish's solitary lantern, the velvet black squid's inky flash, the laser beams of the loosejaw, and the arrested spark of a startled ostracod. In their glow, find calm. In their mystery, find wonder. And in their unending dance of light, feel yourself drift toward sleep. As your breath finds its deepest rhythm, carry with you the secret light shows of the ocean's night. Know that even in the darkest reaches, life finds a way to shine. In that knowledge, rest easy. The ocean's creatures of bioluminescence will keep watch in the silent depths, guiding you toward dreams lit by living stars. The sea at dawn feels endless, a calm expanse of silver ripples that stretch to the horizon. You stand on the deck of a research vessel, the salt spray cool on your skin. Below you, the water hides a secret deeper than any canyon on land, a place where light falters and pressure crushes glass. Far beneath the gentle swell, Earth's deepest scar yawns, the Mariana Trench, a silent world of unimaginable weight. As the submersible's lights dim and the hatch seals, you feel the first tremor of anticipation. The engines hum softly, and the vessel begins its descent, slipping beneath the surface into a twilight of fading blue. Above you, shafts of sunlight shrink to ribbons that curl and fade. Around you, the water cools. At 30 meters, the warmth of the sun has vanished. At 1,000 meters, a hush deepens, as if the sea itself holds its breath. Deeper still, the metal hull groans. Every meter adds hundreds of kilograms of weight per square inch. At 4,000 meters, the water exerts 400 atmospheres, 400 times the pressure at sea level. At 10,000 meters, the number climbs to more than 1,000 atmospheres, a crushing embrace that would condense air into liquid if it could. In the Mariana Trench, at the Challenger Deep, the ocean floor lies nearly 11 kilometers below the surface, more than 2 kilometers deeper than Mount Everest is tall. Geologically, the trench is born of collision and surrender. The Pacific Plate, some of the oldest oceanic crust on Earth, slumps beneath the lighter Mariana Plate. As the older plate bends and dives, it drags the seafloor into a crescent valley more than 2,500 kilometers long and up to 70 kilometers wide. In that silent convergence, Earth's innards surface in plumes of tectonic heat, while the surface above gives way to a void of shadow. The first echo, sounding in 1875 by HMS Challenger, hinted at the trench's depths, recording more than 8,000 meters. Yet it was not until January 1960 that human feet touched Challenger Deep's floor. In the bathyscaphe Trieste, Jacques Piccard and Don Walsh pierced the black water, descending for almost 5 hours until they rested on soft mud laced with broken shells and strange debris. Their call from the abyss, "We are on the bottom," rang through the hull and back to the world above, a triumphant whisper in the global silence. Decades later, in 2012, filmmaker James Cameron piloted the Deep-Sea Challenger alone to the same depths, mapping uncharted ridges and capturing high-definition images of a world no one had seen. Each descent illuminates only a tiny circle of silt and stone, yet every frame reveals new wonders. Ghostly amphipods, drifting like living snowflakes, tiny fish with translucent bodies and oversized eyes, single-celled life forms thriving in conditions that would crush most organisms. Mapping Challenger Deep remains a slow endeavor. Multi-beam sonar paints rough contours, revealing a small, slot-shaped valley nearly 20 kilometers long and 8 wide. To fill in the details, autonomous underwater vehicles drift thousands of meters down, their lights weak ribbons that skim over sediment layers and microbial mats. Each survey adds a brushstroke to our mental atlas of the deep, yet more than 80% of the ocean floor remains unseen at high resolution. In the crushing dark, temperatures hover just above freezing around 2 degrees Celsius. A thin layer of near-freezing water cloaks the abyss, carrying oxygen trapped by polar storms thousands of miles away. Here, heat is a whisper, and life adapts by slowing its heartbeat, winding its metabolism down to a barely perceptible hum. In the twilight above, creatures race by. In the abyssal plain below, life persists in the gentlest of rhythms. Microbial life abounds. Bacteria called monothalasmia have been found at depths of 10 kilometers, metabolizing compounds we can barely name. Their filaments carpet mud and clay, forming invisible networks that recycle nutrients and bind particles. These microbes feed on sinking marine snow-organic detritus from sunlit waters above or on hydrogen sulfide seeping from fissures. Even without sunlight, chemistry becomes the engine of life. Among the first multicellular animals you see are amphipods, shrimp-like crustaceans that drift in curious shoals. Under your lights, they glow faintly, their translucent limbs pulsing as they hover inches above the sediment. They feed on detritus and microbes, scuttling over the mud in clusters that seem to dance in slow motion. In their simple forms, you glimpse the ancient roots of animal life, reminders that every lineage carries memory of the deep. Further out, a gelatinous snailfish floats past, its body like a wind-blown cloud. It drifts without effort, its dense flesh withstanding pressure that would collapse human lungs. Its skin ripples with faint patterns, and its eyes, large and unblinking, reflect your lights like ghostly beacons. This fish is a sentinel of the trench, a species adapted to a world no sun can reach, no warmth can touch. Rocks and nodules litter the valley floor, manganese nodules that grow at rates of millimeters per million years. Each sphere, black and pitted, holds metals essential for our technologies. Deep-sea mining proposals envision dredging these nodules to feed battery and electronics industries. Yet each removal scars the seafloor, erases habitats we have barely begun to understand, and sends plumes of sediment swirling into unseen corners. As your submersible drifts, you feel the silence press in. No birdsong, no wind, no waves. Only the distant hum of vents warm water escaping from cracks in the crust, and the mechanical thrum of your own engines. Every sound you hear becomes amplified in the emptiness. Each creak and hiss a reminder that this is a frontier of solitude, where no human ear has echoed before. The horizon of the trench stretches flat in every direction. No rocks, no canyons, no wreckage, only flat mud and the occasional ridge formed by tectonic forces. Life here clings to rare blemishes. A piece of wood fallen from above, the skeleton of a whale carrying communities of bone-eating worms, or microbial mats springing from chemicals seeping through cracks. In these islands of sustenance, complex ecosystems emerge, a testament to life's tenacity. On one dive, a baited trap drew in scavengers, squat lobsters with spindly legs, brittle stars with arms outstretched, and crustaceans that crawled over each other to reach the prize. In that moment, the trench floor became a banquet hall, lit by the glow of the trap's scent, a feast signaling opportunity in a land of scarcity. Even hydrothermal activity reaches these depths. Sulfide-rich fluids ooze from vents, creating localized oases of warmth and chemistry. At those seeps, bacteria oxidize methane or hydrogen sulfide, nourishing communities of clams and tube worms aliens in the abyss, colonies anchored to warm rock in a sea rendered cold. Measuring life here demands robotic tools. Remotely operated vehicles lower cameras and sample arms, collecting water, sediment, and creatures. Pressure-tolerant bottles seal in the trench environment, allowing scientists to study live specimens above sea level. Each retrieval is a fragile triumph, a gene discovered, an enzyme characterized, a clue unlocked in the puzzle of Earth's biosphere. Historic and modern divees alike reveal plastic fragments resting at the bottom bags, wrappers, and microfibers that drift through every ocean current. In the deepest valley on the planet, human debris settles among the mud, evidence of a world more interconnected than geography would suggest, a reminder that no place is beyond our reach, no depth beyond our impact. Exploration of the trench shapes our understanding of life's limits. If creatures can endure 1,000-bar pressures and near freezing temperatures, what does that mean for life on other worlds? Scientists look to Europa, Enceladus, and Titan, moons where subsurface oceans may host hydrothermal activity. The Mariana Trench becomes a laboratory for astrobiology, a model for ecosystems born of chemistry alone. Yet each expedition is fraught with risk. Hull breaches, equipment failures, and the unknown perils of the deep test the mettle of every explorer. Every descent is a gamble. If cameras fail, if lights go out, if communication cuts, the abyss can claim both machine and crew. The margin for error disappears under the weight of 10 million kilograms per square meter. As your dive draws to a close, the submersible's thrusters reverse. You begin the ascent, passing through layers of dark and cold until the faint glow of the twilight zone returns. At 200 meters, a plume of lanternfish drifts by, their bioluminescent spots paling against the returning light. You rise into the mesopelagic, then the euphaic, and finally break the surface into a sky ablaze with sunset hues. On deck, you feel the sun's warmth in a new way. You breathe deeply, tasting salt and fresh air together. Behind you, the trench lies silent once more, a record of extremes, a cathedral of pressure, a testament to life's resilience. You carry its memory like a secret, a promise that even in the deepest darkness, life endures. As night falls and you rest in your bunk, imagine the crushing depth below, the quiet drift of microbial mats, the slow pulse of amphipods, and the ghostly glide of snailfish. Let the thought of this silent abyss lull you into sleep, a reminder that the planet we call home holds mysteries still beyond our reach, and that in the heart of darkness, life still finds a way. A hush falls over the open ocean as a massive form drifts beneath the waves. Above, ship decks creak in the breeze. Below, the water holds secrets in its inky depths. When a great whale dies, its lifeless body begins a final descent, a slow, silent tumble through layers of blue, punctuated by passing schools of fish and drifting plankton. At last, it settles on the seafloor, becoming the centerpiece of a haunting transformation. In that moment, a whale graveyard is born, a decaying giant that will sustain entire ecosystems for decades beneath the waves. The journey begins with the mobile scavenger stage. As the whale's carcass lands, sharks, hagfish, and deep-sea amphipods converge like vultures. Flesh is stripped in weeks or months, leaving only blubber and skeleton behind. The initial feeding frenzy can clear away soft tissues so rapidly that bones appear nearly intact, setting the stage for the next phase of ecological succession. Each bite echoes through the darkness, a pulse of life consuming what was once its own. Once scavengers depart, the enrichment opportunist stage unfolds. Small crustaceans, polychaete forms, and microorganisms colonize the sediment around the bones, feasting on fatty residues and microbial mats. These communities thrive in nutrient-rich sediments, disturbed by the whale's impact, burrowing through mud and detritus. Over 1 to 2 years, the seafloor hums with activity as opportunistic species build populations in the nutrient oasis created by the whale fall. Next comes the sulfophilic stage, when anaerobic bacteria harness chemical energy from sulfate reduction. These bacteria oxidize hydrogen sulfide generated as bone lipids break down, fueling chemosynthetic food webs, much like those at hydrothermal vents. Clams, mussels, and tube worms with internal symbionts cluster around the bones, drawing nourishment from the vent-like chemistry. This stage can last a decade or more, as bones become living centers of chemosynthetic life. Giant tube worms stand sentinel on the bones, their red plumes swaying in faint currents. They lack mouths, housing bacteria that convert toxic sulfides into organic carbon via chemosynthesis. Nearby, vesicomyid clams and small limpets graze on bacterial films, while predatory crustaceans patrol the edges. This complex web mirrors vent and seep ecosystems, yet it springs from the whale's remains, a testament to life as adaptability in the crushing dark. Whale falls act as stepping stones for evolution in the deep. Species specialized for chemosynthesis disperse between vents, seeps, and whale falls, knitting together distant habitats. Genetic studies suggest that these isolated oases foster adaptive radiation new species, emerging from the pressures of deep-sea living. In the silent depths, the whale's grave becomes a cradle for biodiversity. In the seafloor of the North Pacific, a single whale fall supports the survival of at least 12,490 organisms across 43 species, an explosion of life in a realm commonly called the deep sea desert. These creatures range from tiny amphipods to squat lobsters, brittle stars to vestimentiferan worms, all drawn by the promise of nutrients in a nutrient-poor world. The diversity at a whale fall rivals the found at vents and seeps, highlighting its ecological significance. Biologists liken whale falls, hydrothermal vents, and cold seeps to islands of life in the abyss, each powered by chemosynthesis rather than sunlight. Yet whale falls are transient, formed by chance when a whale dies and drifts to the right spot. Their ephemeral nature makes them rare but vital links in deep-sea networks. Each fall is a fleeting oasis that reshapes local ecosystems for decades. Remarkably, a whale graveyard can endure for nearly a century. After the enrichment opportunist and sulfophilic stages, bones enter the final reef stage. Calcium phosphate degrading bacteria etch the skeleton, while hard substrate faunus, conages, corals, and anemones attach to the ribs and vertebrae. Even after 100 years, these bones can support life, long after the whale's flesh has vanished. Whale falls have been documented in both Pacific and Atlantic basins, from shallow continental margins to abyssal depths beyond 3,000 meters. Experimental falls deployed 150 meters have supported communities similar to deep sea sites, demonstrating that lower temperatures and high pressures slow decomposition and extend habitat lifespans. Yet most natural falls occur below 1,000 meters, where cold water and the absence of large predators allow carcasses to settle intact. These depths hover near freezing, and the crushing pressure hundreds of times that at the surface shapes every biological process. Microbial decomposers work slowly, their enzymes adapted to extremes. Amphipods drift in plumes, delicate brittle stars wave arms into currents, and snails scrape bacterial coatings from bone surfaces. Life here moves at a glacial pace, but the whale fall's energy pulse sustains the quiet churn of deep-sea ecosystems. Researchers first glimpsed whale falls in the late 1970s when submersibles and remotely operated vehicles, ROVs, ventured into the abyss. Observations at sites like Monterey Canyon and Santa Cruz Basin revealed towering skeletons encrusted with clams and tube worms, a startling confirmation of theory. Since then, surveys have uncovered dozens of falls, each bearing unique faunal assemblages that deepen our understanding of deep-sea ecology. Studying whale falls demands delicate technology. ROVs equipped with high-definition cameras map carcass outlines, while robotic arms collect tissue and sediment samples. Pressure-retaining samplers bring live animals to the surface for physiological research. Environmental DNI, EDNI, analyses of surrounding water reveal hidden lineages, hinting at species yet undescribed. Each data point expands our knowledge of these ghostly graveyards. Between falls, the seafloor remains largely barren. Organic particles drift down, feeding sparse communities on the abyssal plains. But when a whale carcass settles, it transforms a desert into a banquet hall, its bounty rippling outward in unseen currents. The resulting biological hotspot pulsates for years, then gradually fades as bones dissolve and nutrients disperse, until the next whale falls and the cycle repeats. Whale graveyards also play a role in the global carbon cycle. Each carcass locks away carbon in loam and sediment, sequestering it from the atmosphere for decades to centuries. Microbial and faunal breakdown recycles nutrients into deep waters, fueling life far below the sunlight line. In a world grappling with climate shifts, these processes underscore the ocean's hidden capacity to store carbon beyond the reach of surface currents. But whale falls are vulnerable to human impacts. Deep-sea mining for manganese nodules threatens to clear away bones and associated fauna before ecological succession completes. Plastic debris has been found tangled in bones, entering the deep-sea food web. Noise from seismic surveys may disrupt the migrations of species seeking out these ephemeral resources. Protecting whale graveyards calls for international cooperation and deep-sea conservation zones. As you drift away from the last bones, your lights fade once more into abyssal darkness. The whale fall recedes into shadow, a monument to life's tenacity in a crushing world. Yet its memory lingers, a silent library of species, each page written in biochemistry and bone. The deep ocean holds these ghostly cemeteries like secrets in a vault, waiting for explorers courageous enough to descend. When your submersible ascends, the water warms and light returns in rippling shafts. Schools of lanternfish shimmer in the twilight, reminding you that life pulses at every depth. On deck, the starboard rail feels familiar under your hand. The air tastes softer, and the world above seems both brighter and more fragile. Beneath you, whale graveyards continue their quiet work, a testament to death's power to give life in the ocean's darkest corners. In the hush before sleep, let the image of a whale skeleton, its ribs arching like the keels of sunken ships, drift through your mind. Imagine tubeworms swaying in invisible currents, amphipods drifting like living snowflakes, and bacterial mats glowing softly against bone-white shafts. Rest in the knowledge that even in the most extreme realms, nature weaves cycles of decay and renewal. The whale graveyards stand as haunting reminders. In endings, there can be beginnings, and in silence, the deepest stories of life take shape. A hush lies over the water when you hear the creaking of an unseen keel and the whisper of sails in a wind that doesn't to blow. Ghost ships drift at the edge of vision-abandoned galleons with tattered flags, hulls empty of crew, their lanterns glowing dimly as if held by unseen hands. These phantom vessels haunt sailors' tailies, drifting homeward with no soul on deck, their timbers groaning with the weight of secrets carried across decades or centuries. Shipwrights long ago believed that a ship's spirit could linger in her timbers, and when a vessel met a violent end at sea, through storm, reef, or conflict, that spirit might guide her hull onward. Mariners whisper of the Mary Celeste, found unmanned in 1872, with provisions intact and no sign of violence. Her lifeboat was gone, and her bell rang beneath a sky free of storm, a mystery that still drifts through time like fog on the Atlantic. Other tales speak of the Flying Dutchman, condemned to sail the Cape of Good Hope forever. Legend has it that in the 17th century, the Dutch East India Company captain refused to turn back from a storm, and slew a crewman, cursing his ship to drift the seas until Judgment Day. Sightings of her red glow on the horizon were thought to foretell doom, and her phantom sails became a symbol of defiance and divine wrath. Beneath northern skies, the ghost ship Octavius is said to roam Arctic waters. Captained by a man who pushed his vessel beyond known limits in pursuit of the Northwest Passage, the Octavius vanished in the late 1700s. 19th century whalers claimed to find her immobilized in ice, her crew preserved at their stations, frozen in time. By sunrise, she vanished again, leaving only the rime of legends on the deck's rails. Alongside these spectral vessels lie sunken ports and drowned metropolises, lost chapters of human history waiting in silent depths. They recall ages when coastlines lay farther seaward, when tectonic shifts or great floods swallowed harbors whole. Many of these submerged sites blend fact and folklore into a tapestry of half-remembered marvels, driving archaeologists and dreamers alike to peer beneath waves in search of vanished stones. Plato's tale of Atlantis remains the most enduring of these legends. He described a kingdom beyond the Pillars of Hercules, an empire of marble temples and canal-lined rings whose people grew arrogant and fell out of favor with the gods. In a single cataclysmic night, the island vanished beneath the sea, leaving behind only a moral warning against hubris. Though no archaeological trace confirms its reality, Atlantis persists as a metaphor for lost glory and the impermanence of human achievement. Few myths resonate more strongly than the Breton legend of Ais. Built on land reclaimed from the sea by King Gradlon and his daughter Dahat, the city thrived until its inhabitants' sins angered the sea goddess Dahat had unwittingly summoned. One night, the ocean broke through Is's dikes, swallowing streets and palaces. King Gradlon escaped on horseback, but the hut was lost forever. To this day, Breton bards still sing of Ise's bells, heard tolling faintly beneath storm-tossed waves. Beyond myth, archaeologists have uncovered real sunken cities whose ruins hint at vanished civilizations. Off the Nile Delta lies Thonis Heracleion, once a bustling Egyptian port known to Greeks as Heracleion. Thriving from the 8th century BC, it was Egypt's principal gateway for trade before earthquakes, storms, and rising waters submerged it around the 8th century AD. Rediscovered in the early 2000s, its sunken temples, statues, and warships have emerged from murky depths, revealing a city of marble colossi and gilded sanctuaries. In the clear, shallow waters off southern Laconia rests Pavlopetri, a city laid out on a perfect grid as early as 3500 BC, buried beneath the waves around 1000 BC by earthquakes. Its streets, tombs, and courtyards remain remarkably intact. Discovered in 1967, Pavlopetri offers a window into early urban planning, with pottery shards and stone structures that speak of bustling markets and daily routines under Aegean skies long since drowned. Between Posillipo and Baia, along the Bay of Naples, lie the ruins of Baia, once the Las Vegas of the Roman Empire. Here, patricians built villas with thermal baths and dazzling mosaics. Between the 3rd and 5th centuries, Adi, volcanic bradyseas and subterranean groundswell, and rising waters sank streets and promenades. Underwater archaeologists now map sunken piers and frescoed rooms, piecing together the riotous life of emperors' retirements beneath shifting seas. Off the coast of Alexandria, modern explorers have revealed Antirhodos, once Cleopatra's island palace. Lost in a tsunami and earthquake in 365 A, the site lay buried beneath mud for 16 centuries. When rediscovered in the mid-1990s, Frank Gaudio's team raised granite columns, sphinx fragments, and jewelry, all bearing witness to the Queen's opulent reign. Her royal harbor, temples to Isis, and the palace foundation emerged from the waves like ghosts of Ptolemaic splendor. Each of these sunken cities fell to geological forces: subsidence, seismic upheaval, tidal bores, and rising seas that overwhelmed human defenses. When harbor walls crumbled or deltaic sands shifted, communities adapted or abandoned settlements to higher ground. Over centuries, memories faded. Inscriptions worn by salt water and storms vanished from temple walls, leaving little more than scattered bricks and fanciful tales whispered across generations. Underwater excavation demands patience and care. Research vessels tow multi-beam sonar that paints seafloor contours in false color maps. Remotely operated vehicles descend on cables, their lights cutting through murk as robotic arms lift amphorae and chisel away encrusted stone. Divers suit up in specialized gear, wrangling cameras and dredges to sample mud layers. Each artifact must surface intact, for a cup rim or seal impression can rewrite the histories of undersea kingdoms. Ghost ships and lost cities alike remind us that the sea preserves as much as it destroys. Cold, low-oxygen waters slow decay, entombing timbers and ceramics in silt. Organic remains linger beneath anoxic layers, while metal and stone structures resist corrosion for centuries. Marine archaeologists find cargoes of amphorae sealed with resin, cargo lights still bearing fish scales, and even papyrus fragments whose ink survives in the right conditions. The line between myth and reality blurs beneath the waves. Tales of the lion city of Shandao Lake in China, or the drowned Neolithic village of Atlat Yam in Israel, echo Atlantis in miniature real sites swallowed by rising lakes and rivers, not chasms of the open ocean. Their discoveries have validated oral traditions, linking folklore to events such as sea level rise at the end of the last ice age and tectonic subsidence in Mediterranean basins. Sunken relics also echo human migration and trade. Amphora stamps trace wine shipments from Rhodes to Rome. Beads crafted from Afghan lapis lazuli surface in Egyptian harbor sediments. Roman merchant shipwrecks appear alongside Ottoman galleons, a succession of cargoes marking the ebb and flow of empires. In one trench off Sicily, archaeologists found anchors from Phoenician traders intermingled with Byzantine ceramics, an underwater museum of shifting power and commerce. Yet the sea does not yield its secrets easily. Currents sift away layers of sand, and biofouling blankets every surface. Over centuries, coral, barnacles, and tube worms encase statues and columns, turning them into living reefs. Removing these colonies risks destroying both the artifact and the habitat it now supports. Conservators tread a fine line between excavation and preservation, often leaving ruins in situ and documenting them in situ with 3D photogrammetry. The romance of ghost ships and lost cities stirs our imagination and drives scientific inquiry. Documentaries drift from deck to deep, following submersible lights across ruins and skeletal hulls. Virtual reconstructions transpose seabed scans into models of vanished isles and plazas. Historians search archives for port registers, inscriptions, and sailors' logs to pinpoint lost harbors. Each data point refines our maps of vanished worlds, one datum at a time. As the tide of knowledge rises, so do calls for protection. Under the United Nations Convention on the Law of the Sea, submerged cultural heritage falls in part under UNESCO guidelines. Nations designate marine protected areas around key sites like Baia and Thonis Heraclean, restricting trawling and mining. International teams share data in open repositories, preserving images and bathymetry for future generations, ensuring that these ghostly graves remain not only found, but honored. Ghost ships and lost cities teach us of impermanence and resilience. They remind us that coastlines are dynamic, sea level ever-shifting, and human constructions vulnerable to forces far older than any civilization. Yet they also show adaptability, settlers moving inland, ports rebuilt on higher ground, traditions revived in new harbors. In this dance between land and sea, we find lessons for our own times of climate change and coastal erosion. In the hush before sleep, let these stories drift through your mind like phosphorescent waves. Picture the Mary Celeste's silent hull bathed in moonlight, the drowned columns of Heraclean rising like ghosts from the bay, Cleopatra's palace gates yawning open beneath a sunlit rippling surface. Imagine divers' lamps sweeping across Aphrodite's temple in Baia, and lanternfish dancing through Pavlopetri's sunken streets. When you awaken, carry with you the memory of these submerged worlds, an enduring whisper that beneath every calm sea lies a tapestry of human ambition, loss, and discovery. And know that, even when civilizations vanish, their echoes endure in the silent depths, waiting for us to listen. A hush lies over the deep ocean, broken only by the faintest pulse of sound traveling unseen through the water. There is no wind here, no crashing waves, only the low rumble of tectonic plates shifting miles away and the soft hiss of distant whales calling in solitude. Beneath the crests of rolling currents, a network of hydrophones' underwater microphones, suspended in the dark, captures these whispers of the deep, recording noises that defy easy explanation. Some are brief pops or bloops, others long, haunting moans. Together, they form an orchestra of mystery that invites us to listen and wonder. In 1997, a sound rippled across the Pacific so loud that multiple sensors 5,000 kilometers apart all registered the same signal. It was a deep, rising pulse, lasting nearly a minute, strong enough to reveal its source almost anywhere in the ocean. Scientists at NOEA's Pacific Marine Environmental Laboratory named it the bloop. Its profile did not match any known animal, nor the rumble of undersea earthquakes or volcanic eruptions. For a time, some even speculated it might be the song of a creature far larger and stranger than any known whale. Years later, Further studies showed that the bloop matched the acoustic signature of icequakes, glacial ice cracking and calving off Antarctica's coast. Yet even with that explanation, the bloop retains its eerie beauty, a reminder that our planet's natural forces can still surprise us. A decade earlier, in 1991, an unanswered hydrophone array began picking up, a different song, a long train of narrow-band pulses ascending in frequency over several seconds, each upsweep echoing through the Pacific. The pattern repeated slowly, surging in springs and autumns, fading in summer and winter, as if nature were breathing in and out. Scientists first guessed undersea volcanoes might produce it, but no eruption matched the sound's steady rhythm. The upsweep's volume has slowly declined since its discovery, yet it still reaches sensors thousands of kilometers away. Its origin remains unknown, an ongoing invitation to imagine what giant engine or shifting crust could be calling in low, drawn-out sighs. Not far behind came the whistle, a steady tone that cleaves through the ambient noise like a tuning fork struck underwater. It appears at intervals, rising and falling in pitch for nearly an hour before vanishing. Some hydrophones record it drifting westward across the Pacific, as though carried on the hidden currents that swirl unseen below. Proposals to explain it range from distant volcanic exhalations to the groan of undersea landslides, but none fit precisely. The whistle emerges like an unanswered question, a solitary thread of melody in the deep's vast darkness. Alongside these voiced curiosities lies a collection of grumbling, crackling, and creaking noises that challenge our understanding of undersea geology. Hydrophones off the coast of Alaska have captured low-frequency rumblings so deep and slow they last for nearly a minute, a sound nicknamed Julia. It emerges in the northeastern Pacific, a test of patience for any listener, rising and fading like a freight train in the distance. Researchers trace Julia's source to magma migrating beneath the seafloor near volcanic ridges, but the precise mechanics remain concealed. Each time it rolls across the abyssal plain, it reminds us that the Earth's interior is never truly still. In the Mediterranean, hydrophone arrays have recorded skyquakes, sudden crackling booms deep underwater, as though thunder had leapt from storm clouds into the sea. Local fishermen and coastal villagers have reported similar rumbles for centuries, mystifying blasts that shake windows but leave no clouds overhead. Scientists now suspect undersea landslides or abrupt shifts in fault lines, but each rumble resists easy categorization. It arrives without warning, echoes against submarine canyons, and vanishes as swiftly as it came, leaving only trembling hulls and startled crews. Even among the songs of wind and volcano, voices of living creatures weave through the darkness. Most are familiar whales singing haunting melodies, dolphins clicking in playful conversation. But one call stands apart, the lonely call of the 52 Hz whale, a creature that sings at a frequency unlike any other. Discovered in the late 1980s, this whale's song drifts across the Pacific, a single note in a band of voices tuned to different frequencies. Other whales do not answer, and no one can say whether this solitary singer is alone by choice or by nature. It swims beneath the waves as a symbol of isolation, a creature whose call touches us more deeply because we cannot share it. In Arctic waters, hydrophones record a high-pitched ping that resounds through the channels between ice flows. Scientists call it the ping of Fury and Hecla Strait, detected during summer ice melt and thought to originate from the shifting edges of glaciers scraping across bedrock. The sound echoes under the ice canopy like metallic fingers drawn across a frozen harp. Each season, as the ice regrows, the ping fades, only to return when warm currents loosen the frozen walls. It marks the rhythms of climates at the poles, a living testament to ice's power and fragility. As intriguing as these natural noises are, some sounds defy both biology and geology. In the Gulf of Guinea, researchers once heard a sequence of 3 rapid shouts that did not match any known marine creature. Dubbed Biosound X, it appears sporadically near seamount chains and remains unidentified. In the Indian Ocean, sensors have recorded a deep screech, a brief, high-frequency burst, unlike the squeaks of shrimp or clicks of dolphins. It blares and dies out in seconds, an acoustic exclamation point with no author. These anomalies challenge scientists to refine their catalogs and push the limits of acoustic detection. Underwater seismometers add another layer of complexity, listening for tsunamis and earthquakes, but also picking up hums that seem to come from nowhere. In the Northeast Atlantic, detectors have traced a persistent low-frequency hum, the hum that reverberates beneath the Canary Islands. Ships, pipelines, and distant storms don't fully account for its presence. Oceanographers debate whether it stems from tiny volcanic tremors or Earth's rotational resonance. Yet the hum lingers like an unresolved chord in a symphony of noise. Even human voices have found their way into the deep's acoustic tapestry. Shipping lanes roar with engines and propellers churning water. Sonar pings slice through marine sanctuaries, and oil rigs throb with drill bit echoes. Researchers have had to learn to distinguish these anthropogenic intrusions from natural marvels. In some areas, the drone of tanker traffic masks the melody of migrating whales. Military sonar can stun or strand living creatures attuned to frequencies for millions of years. By comparing recordings between protected marine reserves and busy ports, scientists map the growing impact of human noise on the seas. Despite the puzzles, each unexplained sound carries a sense of wonder. Hydrophones arrayed across the ocean floor chart a world of creaks, chirps, and choruses, an audio landscape that remains more mysterious than the most remote jungle. Scientists now deploy gliders equipped with ambiental hydrophones, drifting thousands of kilometers along programmed transects to capture every nuance. Autonomous vehicles hover near undersea mountains, sending back live feeds of ambient noise. By combining these data streams, researchers hope to map the seafloor's hidden rhythms and isolate the anomalies that still defy explanation. The study of these sounds is as much art as science. Spectrograms' visual representations of frequency over time unroll a landscape of peaks and valleys, each crest a distinct tone, each valley a quiet pause. Analysts trace lines of sound like cartographers, mapping mountain ranges, noting when signals fade before drifting back into the range of human hearing. In the lab, they splice hydrophone recordings together, slow them down, or speed them up to reveal patterns otherwise lost. In this way, they transform raw noise into stories of ice and magma, whales and unknown wonders. For listeners, the effect can be haunting. Many who hear a sped-up clip of the bloop feel a shiver of awe as though the ocean itself has spoken. The upsweep becomes a song that fills a quiet laboratory with pulsing vibrations. The whistle, once isolated, resonates like an otherworldly wind instrument. Even the low groans of tectonic plates emit a primal power, reminding us that Earth's crust is never still. These recordings have found their way into museum soundscapes, planetarium shows, and ambient music tracks, bridging science and art in one continuous current of sound. Yet most of the ocean remains silent to our ears, its secrets locked beyond the range of both satellites and ships. New networks of hydrophones expand our reach, descending into deeper trenches and broader basins. Each deployment yields hours of recordings, most filled with familiar rumble, but scattered within are the impossible noises, unexpected pops, drawn-out moans, and flickers of light and sound waves. These anomalies inspire expeditions to cross the Pacific, circumnavigate Antarctica, or probe mid-Atlantic ridges, chasing echoes through miles of water. As you drift toward rest, imagine the deep's grand concert playing on unseen speakers. Feel the slow pulse of Earth's heartbeat and the low groan of Julia. Picture icebergs groaning in the night silence, their fractures sending bloops across the Southern Ocean. Hear the lonely song of the 52 Hertz whale calling into emptiness, Let the chorus of upsweeps, whistles, and hums lull you deeper into contemplative calm. In the quiet of your mind, you stand on a listening post between sky and seabed, the secrets of the deep unfolding around you. Beneath each curious noise lies a story of shifting plates, cracking ice, and animals that speak in frequencies beyond our normal range. Some stories find neat endings, explained by glacial calving or venting magma. Others remain open puzzles, invitations to wonder what invisible forces shape the world beneath waves. The ocean is vast and mostly unexplored. Every faint pulse carries a fragment of the unknown. When silence falls again, remember that it is never complete in the ocean's hidden depths. The sounds of Earth continue to be written in waves of water, waiting for us to listen. You drift on the surface as dawn's pale light shivers across the waves. The sea is calm, its skin unbroken by wind or swell. Yet beneath lies a world of fire. Far below, at depths where sunlight never reaches, Earth's molten heart breathes through hidden chimneys. Here, in a realm of crushing pressure and freezing cold, underwater volcanoes reshape the seafloor in silence, rivers of lava carving new crust, unseen but unstoppable. Imagine descending in a research submersible. At first, the blue light fades in ribbons as the hull slips below 100 meters. By 200 meters, day is gone, and your lights pierce only a few meters ahead. You pass through the twilight zone. Creatures, glowing with their own lights, drift past and enter the black abyss. Then the first echoes reach you, low-frequency rumbles that hint at forces beyond sight. You are approaching a volcanic vent on the mid-ocean ridge. Most of Earth's volcanic activity happens underwater. A long seafloor spreading centers giant cracks where tectonic plates pull apart, magma wells up from the mantle. As it meets cold seawater, it cools instantly, forming pillow lavas, bulbous shapes stacked like cushions on the abyssal plain. These pillows crack and weld in place, building the new ocean crust in silent, rhythmic pulses. Sheet flows of basalt can spread hundreds of meters from the vent, blanketing the floor with fresh rock that was molten moments before. At the ridge's summit, you see the vent fissures, long cracks in the basalt, each a crackling generator of new ground. The water around them ripples as heat and chemicals spill out, but no steam rises. The melting point of rock meets the freezing point of water, creating a boundary layer only centimeters thick. Below you, temperatures inside the fissure may exceed 1,000 degrees Celsius, yet a meter away the water stays near 2 degrees. This violent contrast carves chimneys of iron and sulfur minerals, towers of stone that capture the vent's lifeblood in silent columns. You circle one such chimney, its surface pocked with miniature caves and ledges. Here and there, microbial mats glow faintly, colonies of bacteria that feast on sulfur compounds rather than sunlight. Though true hydrothermal vents host the richest seafloor communities, even along cooler, basaltic flows microbes pioneer the fresh rock. They cling to cracks, secreting acids to bore into the stone and unlock nutrients, slowly transforming bare lava into surfaces fit for more complex life. Above the flows, fish and crustaceans hover in cautious numbers. Deep-sea shrimp wheel through the water in slow arcs, their eyes adapted to the faintest glow. Brittle stars carpet the black rock in writhing carpets, capturing marine snow far above. Each organism arrived on currents, drawn by chemical trails and the promise of a feast on new rock microbiomes. The fire of the volcano, though hidden, seeds life across the abyss. At times, eruptions surge. A tectonic tremor shudders through the vessel, and your instruments record a swarm of seismic pulses. Below, fresh lava bursts into life, spouting like underwater fountains from fissures along the ridge. The chemical plume thickens, colors shifting from ink black with iron sulfides to pale white as silica precipitates. Plankton far above may register a subtle change in chemistry, but on deck the sea remains calm, betraying nothing of the fire below. The most dramatic eruptions can flood a valley with lava thousands of meters thick, mapping new plateaus on the seafloor. Satellite altimeters detect subtle bulges in sea surface height, clues to eruption volumes of millions of cubic meters. Fiber optic cables lying on the ocean floor double as seismic sensors. When they vibrate, engineers can pinpoint the time and place of eruptions. In that way, the world listens to submarine volcanoes in real time, even when our eyes cannot see. You linger over a recent flow, its glassy surface still smooth where pillows have not yet broken. Tiny fragments of basalt, called hyaloclastites, drift in the current like black dust. Each fragment carries a record of its birth gas bubbles frozen in place, crystals etched by cooling rates, and rare pockets of volatile elements. Geologists will later analyze these samples to trace the magma's journey from mantle to crust, unraveling the story of Earth's interior. Beyond spreading centers, underwater volcanoes also rise at subduction zones, where one plate plunges beneath another. Here, andesitic and rhyolitic magmas form steeper, more explosive eruptions. In the Pacific Ring of Fire, chains of seamounts and island arcs mark these submarine giants. Vega volcano off Alaska, Kawashi in the Solomon Islands, and Hunga Tonga Hunga Ha'apai in the South Pacific have all erupted explosively, sending steam-driven tsunamis across the ocean surface and plumes of ash into the stratosphere. The 2022 Hunga eruption was a testament to this power. Satellites spotted an ash column 40 kilometers tall, the highest ever recorded. Seismic networks trembled, and hydrophones registered the blast's echo as far away as Alaska. Days later, research vessels found the seafloor blanketed in fine ash, the fallout settling through 1,000 meters of water like pink snow. Microbes suffocated beneath the ash, but others harnessed the chemical nutrients it delivered, sparking blooms of chemosynthetic life in unexpected places. Each underwater eruption reshapes not only the seafloor, but also the global pulse of carbon and heat. New crust spreads, carrying heat from the interior to the ocean. Carbon dioxide dissolved in the magma feeds the water above, altering acidity in the deep. In some seamounts, gas hydrates ice-like compounds of methane form in the cracks, storing energy until tectonic shifts release them in sudden slides or seeps. Volcanic islands also emerge and disappear in the waves. Surtsey, born in 1963 off Iceland's south coast, rose from 130 meters below the sea to 20 meters above in a single eruption. For years, scientists studied its nascent ecosystem. Mosses, gulls, and later leeches colonized the new land. Underwater, the eruption built a volcanic plateau, creating habitats for fauna that still thrive on the seamount slopes. The life cycle of these islands is cyclical. Wave erosion, rain, and frost slowly carve them into lower hills. In centuries, they sink back beneath the sea, their soils washed away, leaving only submerged skeletons of basalt. Those bones become coral reefs and fish nurseries, islands of life around extinct volcanoes. In that way, volcanic fire seeds not just new rock, but entire ecosystems above and below the waves. Exploring these wonders demands technology that can survive the abyss's extremes. Manned submersibles with spherical hulls descend tethered by steel cables, their occupants bathed in the glow of lithium arc lights. ROVs, robotic scouts, carry powerful strobes and high-definition cameras to map flows and measure temperatures with metal probes. AUVs drift, programmed routes, gathering bathymetry and chemistry data, returning to the surface like oceanic bees, bringing nectar from far-flung blooms. Each mission is a dance with danger. At depth, a single crack in a seal can flood a cabin or short-circuit instruments. Time is measured in battery life and compressed air. Every minute counts. Yet the reward is the glimpse of fire under the waves, a reminder that Earth is alive, its interior stirring ceaselessly beneath the tranquil sea. Scientists piece together these stories with data from distant ships, and here on deck, they analyze video frames of fluid flows, measure lava morphologies, and sequence microbial DNA on fresh basalt. They deploy seismometers on the sea floor to capture invisible tremors and sample hydrothermal fluids to reveal chemical recipes that feed life. In laboratories around the world, these fragments come together, telling the epic of submarine volcanoes. Back on deck, the submersible breaks the surface. As you step into morning air, the world seems unchanged. Boats drift on calm waves, gulls wheel overhead, and the horizon remains a perfect line. Yet beneath lies a landscape remade by fire. Pillow lavas, basalt plains, and towering chimneys lie hidden beneath kilometers of water, silent monuments to Earth's restless heart. In the quiet that follows your return, let your mind drift over the seafloor's hidden fires. Recall the roiling magma, the silent black pillows, and the brave microbes that colonize fresh rock. Remember the slow birth of seamounts, the explosive eruptions that shape islands, and the ceaseless hum of tectonics that orchestrate Earth's grand symphony beneath the waves. Night falls again over the ocean. The moon's silver path ripples across the swells, hinting at waters deeper than any valley on land. Beneath, submarine volcanoes slumber, but for how long? Tomorrow, another tremor may signal new fire. Another plume of ash may darken distant skies. And in the silence, the seafloor will continue its quiet transformation, molding new crust, breathing heat, and weaving the tapestry of ocean life on fresh stone. As you drift toward sleep, feel the distant rumble of the mid-ocean ridge echo in your bones. Let the knowledge of hidden fire lull you into gentle dreams, dreams of rivers of molten rock flowing in the dark of microbial pioneers, dancing on basalt, and of Earth's unspoken promise, that beneath every wave unseen forces forever renew our planet in silence. The sea surface lies frozen in a silent tableau, a vast expanse of ice that stretches to the horizon in every direction. Above, the sky glows pale in the long twilight of polar winter. Below, a different world awakens. Imagine yourself sliding beneath the ice shelf's edge, breaking through into dim green half-light. The first sensation is the chill of cold so pure it seems to clear your thoughts. You float under a ceiling of ice, its underside crystalline and ever-shifting. Here, in this frozen realm, silence holds sway, broken only by distant echoes of cracking floes and the faint song of a lone seal below. Drifting forward, you feel the tug of currents flowing beneath the ice. They carry water and nutrients from the open ocean toward the shore, feeding the under-ice ecosystem. Minute bubbles cling to the ice above, creating patterns of light and shadow. You see them drift in filigree designs, like ghostly jellyfish trapped in glass. These bubbles are pockets of oxygen and methane, released as the ice forms and melts. They hint at the life below, an ecosystem reliant on the sliver of light that filters down and the currents that deliver plankton and dissolved organic matter. Beneath the ice, the water temperature hovers just below freezing, minus 1.8 degrees Celsius. But life thrives here. Tiny algae colonize the ice's underside, their filaments waving in hidden currents. In spring, when the sun creeps back above the horizon, these algae take advantage of even a few hours of light. They bloom into mats of green and brown, carpeting the ice with nourishing flakes that drift downward like confetti. These flakes feed zooplankton, amphipods, and small fish, creating a spring carnival of life beneath the white ceiling. In the deeper channels between ice ridges, you glimpse small crustaceans, copepods, and eupausids drifting in swarms. Their bodies shimmer with a ghostly sheen under your lights. Each tiny creature carries its own universe of microorganisms, bacteria, and viruses. They represent the first link in a food web that sustains larger predators. Watch them feed on algal flakes, their mandibles filtering fine particles. In turn, they feed juvenile fish and juvenile krill, whose migrations fuel the great seasonal pulse of life in the Arctic. A flicker of movement catches your eye. An Arctic cod, its body translucent with a tucked-in dorsal fin. This fish has evolved to breathe in cold, low-oxygen waters. Its hemoglobin efficient at capturing every molecule of oxygen. It darts toward a cluster of copepods, snapping them up with practiced ease. The cod swims steadily against the current, a slender ghost flickering through green gloom. Above, the ice shifts in slow tectonic ballet, but here, fish rule a still world where each breath is precious and every meal hard-won. As you glide onward, the first shadows of polar giants emerge. A ringed seal glides past, its round eyes reflecting your lights. Its pectoral fins propel it with effortless grace as it checks breathing holes in the ice above. These seals know the under-ice labyrinths intimately, hauling out onto floes to rest and regurgitate fish remains for pups. Their whiskers trail behind, tasting vibrations in the water-tiny snares that alert them to prey in darkness. The world beneath the ice belongs to both hunter and hunted in an unspoken equilibrium. In deeper waters, beyond the reach of even the faintest glimmer from above, the ambient light falls away entirely. Your spotlight reveals a realm of eternal night, where only your instruments chart the landscape. Here, glass sponges cling to rocky outcrops, their glass-like skeletons flickering under your lights. They filter the water, capturing microscopic particles that drift in from above. Their long, delicate spicules form underwater groves cathedrals of silica, where amphipods and polychaete worms hide and browse. You pause above a field of sea pens, reminiscent of terrestrial flowers swaying in invisible breeze. Each colony extends feathery tentacles to gather fine detritus. Their stalks anchor into soft sediment, sometimes hundreds of meters beneath the ice. These animals live slow, measured lives. Some sea pens may survive decades, unfurling and refurling their plumes to feed on the steady drizzle of organic matter from the under-ice bloom. Their existence is a testament to life's adaptability in the blackest corners of the ocean. Suddenly, a distant crack echoes through the water, a sharp report like a gunshot. You hold your breath as the sound reverberates against the ice ceiling. Icequakes occur when pressure builds within the shelf and releases in sudden shatters. You feel the sub's hull shiver with each blast. Moments later, the crack fades and silence returns. But the echo lingers in your mind, a reminder of the ice's restless nature and the hidden dynamics that sculpt this alien world. Drifting closer to the shore, the under-ice topography begins to change. Ridge systems cast gentle shadows on the seafloor. Drifts of sediment form small dunes. Buried stones and erratics from past glacial advances dot the terrain. You note the presence of sea stars, small, pale protuberances anchored in the mud. They prey on clams and worms, moving slowly in search of food. In their advance, they stir up clouds of sediment, brief bursts of brown turbulence in a world of green and black. As spring advances, the ice above thins and sunlight penetrates in diffuse shafts. You see long green shafts, like underwater pillars, illuminating schools of juvenile Arctic cod. Their bodies flicker like living embers in the gloom. Beneath the ice edge, algae carpets the rocky ridges, their bright green telling of a feast to come. The bloom intensifies, drawing krill herds from the open ocean toward the ice margins. This pulse of life sets the rhythm for entire food webs. Whales, seals, seabirds all time their migrations to coincide with it. Leaping further beneath the ice, you encounter the world's silent apex predator, the polar bear. Beneath the ice shelf, you glimpse a dark shape patrolling breathing holes. Its broad paws churn the water in measured strokes. It swims with methodical power, sensing seals beneath the floes. When it finds a preferred hole, it pauses, its muzzle skimming the water surface for scent. It can hold its breath for minutes, and its vision remains sharp in low light. At the ice edge, It emerges to rest on a floe before diving under once more. This under-ice world is the bear's hunting ground. Venturing beneath thicker ice, you descend into an environment shaped by ancient glaciation. You see striated rock surfaces carved by ice bodies thousands of years ago. Glacial till mixtures of clay and gravel collects in grooves. Amid these sediments, you find burrows of amphipods and brittle stars. They dig into the mud, weaving burrow systems that oxygenate the sediments and foster microbial diversity. These microbes break down organic matter, releasing nutrients that feed higher trophic levels in a slow, ceaseless cycle. At extreme depths under multi-year ice, you notice the increased salinity in stratified layers. Dense, cold brine pools form near the grounding lines of shells, creating pockets of hypersaline water. These pools trap life and chemicals, forming isolated microhabitats with unique species. Brine shrimp and halophilic bacteria exploit these niches, living at salinities lethal to most marine creatures. In the black cold, they thrive, converting available organics into energy in an ecosystem unlike any other. As you trace the continental shelf's edge, the terrain rises sharply. Rocky walls draw close, and the under-ice shelf meets the seafloor. Here, currents accelerate through narrow channels, delivering fresh nutrient blooms and oxygen. Fast-growing sponges and bryozoans attach to boulders, building lace-like colonies that filter the rushing water. Starfish, shrimps, and small urchins weave through these gardens, grazing on microbial films and each other in a fringe biome where the ice's influence wanes. In pockets beneath grounded icebergs, you discover anchor ice formations, stalactite-like crystals forming on rocks and sediments in supercooled water. These structures grow downward, capturing microorganisms and detritus. Eventually, currents detach them, carrying them to deeper realms as bizarre stalagmites floating free. These fragments seed new habitats on the abyssal plain, dispersing ice-origin microbes and altering local biodiversity in an unusual conveyor of life. Return toward the central under-ice zone, and you hear the distant moan of a submarine glacier calving. The hydrophones on your sub pick up low-frequency oscillations, an otherworldly drone that fills you with awe. Each calving event hurls massive ice fragments into the water, releasing shockwaves and pulses of cold fresh water. These pulses reshape under-ice currents and deliver life-giving nutrients toward open waters. Igniting plankton blooms even far from the ice edge. Navigating beneath the ice brings you face-to-face with sensory wonders. The effect of light refracting through moving ice, the hush punctuated by distant groans, the rhythmic click of your instruments, and the soft drift of particles in near-zero visibility. Each moment feels suspended in time, as though you exist in a living painting of green and black. The world above is familiar. Here, you are an explorer in a land of half-realized shapes and whispered echoes. As the sun rises higher in the sky, the ice thins further. Patches of open water appear, reflecting the cerulean sky in stark blue pools. Through narrow cracks, sunlight spills down in vertical shafts, illuminating schools of krill swirling in laser-like spotlights. The under-ice algae glow more brightly, feeding on the rays. In these moments, the boundary between ice and ocean, light and dark, becomes porous, a threshold where life surges in response to each photon. You trace a channel leading toward the edge of the pack ice. The current accelerates as water passes between drift ice flows. Beneath you, the seafloor rises. Living sponges and soft corals carpet the walls. These sessile animals produce mucus nets that trap drifting particles, creating pockets of enriched biodiversity in the mosaic beneath the ice. The walls transform the ice-dominated world into a rocky reef, a refuge for predators like cod and Greenland halibut that hunt by lurking in crevices. Venturing into the polar night's final twilight, you become aware of the rhythmic breaths of seals rising through leads in the ice. Their chatter fills the water in crackling clicks and squeals, half-human echoes of life above. They feed on cod and squid, their blubber insulating them against the cold. Their presence signals a healthy ecosystem one, where apex predators thrive in an intricate web spun by ice, algae, plankton, and fish. As you retrace your path toward the sub's hatch, the under-ice world shifts again. Tides carry fresh water in and out, stirring sediments and renewing oxygen. You pass beneath ridges shaped by tides, each arch and crevice alive with encrusting life. Tiny anemones open their tentacles in the current, and polychaete worms station themselves at strategic points, filtering every flowing drop. Breaking through the ice into cold air, you feel the sun's warmth more deeply. Above, seabirds wheel in calls of glee at open water. Below, the world you leave behind continues its quiet dance, an alien realm of shifting ice, silent predators, and delicate webs. The ice's underside will shimmer again at dawn. Its algae bloom, and its currents carry whispers of life into the dark. As night falls, let this vision settle in your mind. The frozen ceilings of ice, the hushed green half-light, the ghostly forms of cod and sponges, the predators that patrol the labyrinth, and the caretakers that build their homes on rock and sediment. Know that beneath every polar ice floe lies a fragile world of wonder, a realm that demands both our awe and our care. You drift in the silent blue, the warm currents of the tropics giving way to the cool hush of the open ocean. The sun above pools into a single beam that fades as you sink deeper, until at last you stand in a world of shifting shadows and muted light. Here, in the depths where daylight dies, giants of the sea stir in slow motion, creatures so vast and strange that they seem born of dream rather than bone. Ahead, a long, pale ribbon cleaves through the gloom, the mantle of a squid the size of a bus. Its skin shimmers faintly, chromatophores pulsing in slow waves of silver and pearl. There, giant eyes wider than your shoulders turn toward you, reflecting your lights like pale moons. This is Architeuthis dux, the giant squid, a living legend that brushes the limits of human imagination. Its 10 arms trail behind, lined with suckers the size of teacups, each ringed with tiny teeth that clamp down on prey with crushing force. You watch its slow, graceful glide. Hunting in darkness, this master of stealth can detect the faintest ripple of water, sensing krill swarms and lanternfish shoals with precision born of evolution's deepest currents. As you drift, the squid retreats into shadow, its form dissolving into the folds of midnight blue. Not far beyond, something larger emerges, a dark torpedo of muscle and fin Mesonicoteuthis hamiltoni, the colossal squid. Its body is shorter, but broader than its giant cousin, heavier by half a ton or more. Its hooks rotate on swiveling sockets, glinting with menace in your lights. You glimpse its beak, a steel-like parrot's jaw built to shear through flesh and shell. This creature haunts Antarctic depths, a phantom ghost in the sunless trenches, rarely seen, yet undeniably real. Only a handful of specimens have ever been raised to the surface, each one rewriting the metrics of size and strength that once defined possibility. You linger in the cold, imagining the immense pressure that shapes these forms. At 3,000 meters down, the weight of water presses on every cell, yet here, the squid thrive. Their blood runs copper-rich and oxygen-sipping, their gelatinous flesh pliant as rubber, their hearts slow but unyielding. Even the colossal squid's eggs, encased in gelatinous rafts, half your height float in the dark, each speck a promise of another generation of giants. Further on, the water warms slightly, currents converging along a seamount slope. There, in the gray-green half-light, a different colossus drifts into view. It is not a cephalopod, but a shark, a living relic with a mouth as wide as a doorway. This is Rhynchodon typus, the whale shark, the largest fish ever to swim our seas. Its spotted hide ripples in gentle undulations, its dorsal fin moving with the rhythm of a meditative tide. Despite its size 12 meters or more, It feeds on plankton and small fish, gulps of seawater filtering life through sieve-like gills. You watch it vault with ineffable grace, a placid titan grazing on the ocean's smallest wonders. Just behind, a similar shape moves, darker and sleeker. Cedorhynus maximus, the basking shark. Its enormous louvered gill slits open like cavernous doors, drawing in water by the ton. It cruises slowly, mouth agape, as if tasting the currents for plankton blooms. In these shallow midwaters, you drift alongside them, the two giants grazing at twilight, each breath a whisper of kinetic power. Yet these gentle giants yield the stage to a more fearsome phantom, Carcharodon carcharias, if that is indeed the species you glimpse. A flash of raked teeth, a hammerhead's solid flank, a drawn-out arc of steel-gray muscle, the great white shark. But you sense something older, more gargantuan. In the fossil record, Carcharodon's megalodon once roamed these waters, a predator 15 meters long with teeth like machetes. Though extinct, its shadow lingers in every great white that scatters schools of tuna or seals with flashes of predatory elegance. You imagine the deep's toddlers' tiny makos and thresher sharks fleeing in your lights, ghosts of megalodon's legacy still coursing through their genes. As you fall deeper, the giants grow stranger still. A wedge-shaped form slides beneath you. Rhinchabatus australia, the giant guitarfish, its flattened body spanning 2 meters in width. It skims soft sediment, searching for crustaceans buried in the mud. Its tail whips softly, its spiracles lifting sedate breaths behind wing-like pectoral fins. It is a dinosaur among fish, a lineage unchanged for millions of years. Even larger, a phantom emerges in the gloom. Manta birostris, the oceanic manta ray. Its wingspan can reach 7 meters, its cephalic lobes curled like ram's horns. It loops through the water in silent loops, museum gargoyles animated by currents. Its belly spotted with unique patterns, whispers of journeys across oceans, devouring plankton drifts by the trillions. In its slow, deliberate turns, you glimpse the wisdom of eons, the calm authority of a creature too vast to fear or fight. In the abyssal plains below, megafauna take even more alien forms. You peer through soft lights at Bethinomus giganteus, the giant isopod. Its segmented exoskeleton curls like a living pinnacone, each segment larger than your forearm. It drifts across the mud, scavenging on whale falls and detritus, an armored titan of the deep. Nearby, you see stalked barnacles anchored to basalt vent chimneys sessile colossi, with shells bigger than your palm, each filtering particles from chemical-laden plumes. In the darkest trenches, you turn on infrared cameras and catch glimpses of deep-sea creatures so bizarre they defy familiar classifications. A frilled shark, a living fossil, with 60 gill slits and an eel-like body, winds through unseen caves, its flexible jaws parting to swallow prey whole. Its form echoes primordial seas where vertebrates first swam, a relic preserved in perpetual night. Not far off, a cluster of giant amphipods Parapagerus spp drifts like oversized shrimp, each body glimmering with biofluorescence. They thrash long antennae, sensing chemical trails from carcasses thousands of meters below. They number in hundreds at a single bait trap, a swirling storm of 6-legged behemoths feeding on whale bone, a testament to life's tenacity in a world of minimal energy. You turn your lights toward a depression in the mud, where a menacing form waits. A 6-armed octopus known as Halophron atlanticus, the 7-armed octopus. Its mantle alone stretches half your height, and its arms curl like monstrous tentacles beneath a bulbous head. You glimpse its gills pulsing, its suckers large enough to grasp a baseball. This cephalopod, rarely seen by human eyes, drifts in sluggish circles, its intelligence hidden beneath a mantle of anatomical marvel. As you rise through these dark realms, you realize that size in the deep is both weapon and survival strategy. Gigantism conserves energy. Larger bodies lose heat more slowly, smaller mouths need fewer calories, and internal organs scale to function under crushing pressure. Yet gigantism also carries vulnerability, slow growth, late maturity, and a dependence on rare, unpredictable food sources. These megafauna, grand as they are, remind us of life's compromises at the ocean's extremes. Above you, in the mesopelagic zone, even the midwater hosts giants. You see a school of viperfish, and each fish measures over 1/2 meter long, its fang-like teeth curving from a mouth that hangs open even at rest. This creature wears a bioluminescent necklace, a row of photophores that lure prey into the cavernous maw. In the gloom, it drifts in an ambush posture, a nightmare cast in living shadows. Not far off, the stoplight loosejaw flickers red light from its chin, a wavelength invisible to most fish. You watch it stalk among jelly-like siphonophores, its jaw unhinged and drooping, ready to snap up any creature entranced by its hidden glow. Its elongated body and minuscule eyes betray a life spent in perpetual darkness, hunting on stealth and light's manipulation. In the twilight zone, the dragonfishes parade horrid shapes, elongated bodies studded with luminous sails, barbs, and spikes. Each light source a carefully tuned lure or signal. These fish can swallow prey larger than themselves, their stomachs stretching like balloons to hold feasts that may arrive only once in a blue moon. They drift like living spears, each strike a testament to adaptation honed by eons of blackwater evolution. As you near shallower depths, the giants give way to leviathans of another kind, the blue whale Balaenoptera, musculus largest animal ever to live. Even in low light, you see its immense body glide through 50 meters of water, a streamlined fortress of muscle and blubber. Its pleated throat expands like an accordion as it lunges through krill swarms, engulfing millions of prey in each gulp. Its tail fluke, as wide as a bus, presses water in steady strokes that propel this colossus across oceans. You hear its low, resonant calls through the hydrophone's frequencies so deep they rumble in your chest and linger long after the sound has faded. Above you, where light returns, the giants of the deep vanish into the blue. Yet their shadows remain etched in your mind. The undulating arms of giant squid, the hooked embrace of colossal squid, the gentle grazing of whale and basking, the silent drift of frilled sharks and giant isopods, the hunting rituals of dragonfishes and viperfish. Each encounter reveals a realm where size defies expectation and life pushes the boundaries of endurance. As your vehicle breaks the surface, you feel the sun's warmth and smell salt and wind once more. Ships drift on calm seas, unaware of the titans that glide below. You breathe deeply, carrying the memory of giants, a testament to Earth's hidden grandeur. In sleep, let their echoes carry you into dreams of immense creatures, prowling unseen realms. Know that in the depths, life expands its canvas to colossal scale, painting in strokes of muscle and might the endless possibilities of adaptation. In their shadows, we glimpse both nature as fury and its restraint, reminders that even the largest creatures arise from fragile seas and delicate dances of survival beneath the waves. You descend through the inky water until the last sliver of sunlight dies above, and you find yourself in absolute blackness. Pressure presses in on every side, a silent weight measured in tons per square inch. The water temperature hovers just above freezing. In this realm deeper than humans can ever endure without protection, life takes on forms both nightmarish and wondrous. Here dwell the black abyssal creatures, ghosts of the deep shaped by unimaginable pressure and complete absence of light. Your lights sweep across a velvet curtain of darkness, and suddenly a flash of ebony gelatin meets your beam. It is a black seedville, an anglerfish whose mouth yawns wider than its head, its teeth transparent and slanted like shards of broken glass. From a rod on its snout dangles a bioluminescent lure that pulses in icy blue. Prey, drawn by that lonely glow, Drift within reach of those crooked fangs, and one swift flick sends lives tumbling down the angler's gullet. As you drift past, you glimpse the common fangtooth, its name betraying its most striking feature. Though this fish measures no more than 16 centimeters, its teeth tower over its body like dripping ivory daggers. It cannot close its mouth, yet it survives by striking swiftly, its jaws locked open like a trapdoor. Each fang is so long it tucks into grooves in the skull when the creature swims. In this world, proportion yields to function, and being small offers no protection against ravenous adaptation. Further into the abyss, the shape of the pelican eel drifts by, its jaw distended into an immense pouch. The eel's throat expands like a balloon, ready to engulf anything unfortunate enough to brush against its bill. In the crushing dark, where meals may be generations apart, this vessel of a mouth ensures no opportunity is lost. Its black body is ribbon-like, trailing a filament tipped in light, flickering faintly, before it disappears behind folds of midnight flesh. Your lights pick out a delicate filigree on the sediment below stalked sea pens, their feathery plumes locked in slow motion as they sway in hidden currents. These black abyssal corals implant themselves in mud at depths of thousands of meters. Their soft bodies extend polyps like microscopic brushes to sift organic particles from the water. They form ghostly forests, beds of living glass in a world where coral reefs 2,000 meters above would shatter in the cold. Shadows lengthen and condense into the body of the vampire squid. Its 8 arms fuse into a cloak of webbing marked with silver rings. When threatened, it inverts itself, tentacles pointed outward, revealing a ring of bioluminescent photophores that glitter like dying stars. It can trap water in its cloak and jet away in bursts of black water, leaving predators confused by its sudden disappearance. In the abyss, technology is evolution, and the vampire squid wields light and darkness as one. You drift onward and catch the silhouette of the tripod fish. Its pectoral fins extend into 3 long spines, elevating its body above the mud. It perches like a living tripod, scanning for prey that drifts by on the scented currents. At depths of 4,000 meters, the tripod fish trades speed for patience. It waits in stillness, each minute stretching into hours, until the next morsel of life floats within reach of its bent spines. On the bare floor, a trio of giant isopods shuffles across the mud. They hunch their armored bodies and press down with many legs as they move in slow waves. Each segment of their shell is so thick it could crack a diver's hands. These scavengers feast on carcasses that drift down from higher layers, whale falls, fish skeletons, any protein that arrives. They can survive months, even years, between meals, their metabolism slowed to a snail's pace under the abyssal weight. Drifting among them are Black Sea cucumbers, their bodies modeled obsidian and charcoal. They ingest mud and extract the slightest trace of organic matter. Their tube feet flash in microbursts of bioluminescence when disturbed, a warning glow in the silent dark. After contact, they flick off luminous droplets that drift away, distracting predators. In a world where food is scarce, every strategy for survival must be honed to lethal precision. Walls of volcanic rock tower in the gloom, and you see the giant amphipod hauliers inching along them. Each amphipod is the size of your hand, and thousands congregate on a single ridge. They cluster in pods, feeding on bacterial mats that coat the rock. When startled, they release bursts of bioluminescent blue sparks, each flash an exclamation point in the abyss, then swallowed by endless night. Passing through a field of manganese nodules, you glimpse the black ghost shark, the frilled shark slipping through crevices. Its body arches in a sinuous curve, fringed with 6 gills on each side. Its narrow jaws open in a frightening grin of backward-pointing teeth. Though rarely seen, this living fossil harks back to ancient seas. Only a few specimens have been caught. Most live and die unknown, descendants of lineages that survived mass extinctions in darkness. Time dilates as you descend. Pressures multiply, and your suit creaks under forces that would collapse any human lung. Yet the abyssal creatures thrive here. Their cells lack the rigid proteins that would shatter under pressure. Instead, they are filled with flexible gels and surfactants that absorb the squeeze. Enzymes stabilize at freezing temperatures, preserving function when heat dies. Each adaptation reads like a manual for surviving the unimaginable. A flash of tentacles draws you closer, the colossal cone jelly. Its body refracts your lights into rainbow bands as it pulses. Though delicate as glass, it resists the cold and pressure. Cone jellies drift, feeding on small crustaceans, their ciliary rows beating in perfect rhythm. They lack a skeleton, yet they endure where heavier forms cannot. Their black bellies appear invisible from above, a cloak against predators below. Your beam falls on a lone snailfish, clinging to rocky outcrop. It glimmers pale in the gloom, its gelatinous flesh shaped by pressure into shapes that would collapse at the surface. Its blood contains antifreeze-like compounds, preventing ice crystals from tearing its cells. It feeds on amphipods, moving with surprising speed for its environment. Each move sends faint ripples through the water, a ballet in the world's quietest theater. In the distance you see a flicker one of the abyss's true ghosts, the deep-sea dragonfish. Its long, eel-like body is armored in plates that mirror the abyss's blackness. Photophores rim its jaw and line its flanks in living paint. It tracks prey by its own red light, invisible to most animals. When it finds a school of lanternfish, it strikes with lightning speed, jaws swiveling to reveal inward-pointing teeth that trap all movement in an instant. You drift toward an undersea cliff where black hydrothermal vents exhale superheated plumes. A colony of Pompeii worms colonizes the Hodis chimney. Their tails bury into mineral tubes, while their heads emerge clothed in a robe of red bacteria that oxidize hydrogen sulfide. In the blackness, they cluster like floating pincushions, tolerating temperatures no human could survive. Their sheer existence rewrites the definitions of habitability. Above a bone thick with filigree sponges, you glimpse a ghost fish, the barrelli fish. Its transparent head reveals two barrel-shaped eyes, frozen in a permanent gaze upward. Those eyes capture every photon of the faint green glow above, tracking the silhouette of jellies and squid. Its tubular vision grants it extraordinary sensitivity in the archipelago of shadows. Only in the black abyss does such specialization become worthwhile. The abyssal realm remains mostly unknown. Every expedition yields new species forms that glow like embers, crustaceans that drift in clouds of white bioluminescence, snails with fluted shells that glisten in the beam of lights. Genetic analysis reveals lineages older than any terrestrial creature. Each DNA sample and spools a story of survival in silence, a record of adaptation pressed into the most extreme conditions on Earth. Human activity now intrudes deep-sea mining, plastic fragments drifting down, noise from seismic surveys, masking subtle symphonies of the abyss. Yet these black abyssal creatures persist, guardians of an alien world. They survive in a realm unreachable without technology, in pressures that would crush any human. In darkness so complete that light itself becomes a weapon, they thrive creatures both beautiful and terrifying, testaments to evolution's deepest possibilities. As you prepare to ascend, the lights dim and the pressure eases. The giants of the abyss recede into blackness, their shapes dissolving in the water column. Yet their memory lingers, the silent predator in its cloak of darkness, the drifting gelatinous forms, the armored scavengers on the seafloor. In sleep, let their shadows drift across your mind, a reminder that our world holds depths beyond imagination, where life endures against all odds in the blackest reaches of the ocean. You drift at the ship's stern as the echo sounder paints a silent map beneath your hull. Each pulse of sonar reveals a world beyond reach vast chasms and jagged ridges sculpted by tectonic fury, waiting in darkness for a curious eye. The sea surface is calm, but below lies a tapestry of uncharted trenches and rifts that plunge deeper than the tallest mountains stand high, scarred by forces older than human memory. These hidden gullies and crests hold secrets of Earth, as birth and cradle ecosystems unseen by any soul. In the captain's briefing room, charts flicker on a screen, lines of bathymetry traced from satellite altimetry, smoothed into contours reminding you of mountain ranges. Yet these are mountains and valleys beneath the waves, their summits cloaked in pressure and shadow. You know that only a handful of these trenches have ever felt the touch of the submersible's hull. Fewer still have hosted an UV's whirring propellers or a camera's beam. Most remain unvisited, their depths a ledger of untold geologic drama and unobserved life. As you board the research vessel, the air smells of diesel and salt. The crew straps gear into watertight crates, while engineers calibrate multi-beam sonar systems. In the control lab, screens glow with real-time echo swaths of seafloor rising and falling in blues and purples. Here, the mid-Atlantic ridge crests like a spine along the ocean's floor, its axis marked by transformed faults that crack and shift with every tremor. Along its length, hydrothermal vents sculpt chimneys of iron and sulfur, and yet, between the known vent fields, entire rift valleys remain unscanned. The ridge may bisect our maps, but countless side branches, deep grabens, and off-axis fissures await discovery. By nightfall, the ship slows over a sonar anomaly, a V-shaped trough more than 10 kilometers across, its flanks streaked with rough scarps and fault lines. This is no mapped trench. It lies between the Jan Mayen vent field and a transform fault, far from shipping lanes. You stand at the rail, hearing only the hum of generators. In this stillness, it is easy to forget the weight of water pressing down, mile upon mile of darkness above the next unexplored abyss. At dawn, REV Atlantis is deployed, tethered by fiber optic cables to the deck winch. It descends through the thermocline, passing schools of lanternfish and glimmering cone jellies in the mesopelagic twilight. Below 2,000 meters, your lights cut through a cold green haze. The hull creaks as pressure climbs. Every 10 meters adds another kilogram per square centimeter. By 3,000 meters, it is nearly the weight of a car on your shoulders. The only promise of safety is the sturdiness of the titanium sphere that will cradle you in darkness. As Atlantis inches deeper, the sonar track fades from the main lab screen. You navigate by inertial guidance and Doppler log, steering toward a target whose coordinates came from a decade-old survey. No previous camera has glimpsed this seafloor. When you reach 5,000 meters, the Ravez lights illuminate a field of angular basalt pillows, fresh volcanic flows that seem no older than yesterday. Their glassy skins bear fans of tube worms grazing on chemical plumes, as though this seamount's birth was yesterday's event. You realize that Earth's crust is remade here in pulses of fire, each eruption writing a chapter unread by any human. Beyond the pillows, the terrain tilts steeply into a dark canyon. This off-axis trench plunges 8,000 meters. A narrow slot deeper than Everest is tall. Its walls rise like cliffs in a shadowed realm. You hover in silence, feeling the canyon's immensity around you. No sunlight, no moonlight, only your artificial beams cutting through in stark relief. The walls crackle with rust-colored manganese crusts, and here and there, a black smoker hisses small clouds of mineral-laden water. This is a hidden vent community that may have persisted for millennia, sustained on Earth's internal heat, while the world above changed name after name. Descending further, you witness life in miraculous abundance. Ghostly sponges anchored to basalt spires, their glass skeletons filtering the faintest trickle of organic carbon. Encrusting clams cling to sulfide-stained walls, feeding symbiotic bacteria that oxidize hydrogen sulfide. You crane your head to follow a cluster of bright red tube worms, their plumes pulsing in invisible currents as they feed on toxic vent fluids. Here, kilometers beneath the waves, Geosynthesis writes an autobiography of adaptation, uninfluenced by the sun's gift. At 9,000 meters, the REFO reaches the trench floor, a plain of black mud interrupted by boulders and ridges formed by subducted ophiolites. In mud so fine, it resembles powdered ink. Tiny amphipods swirl like living clouds. Their translucent bodies glow faintly as they drift in search of detritus, each a slow dancer in the abyssal gloom. You pilot the ROV down to the mud, craning forward to let its robotic arms stir a gentle swirl. The muddy vortex reveals fossils of coccolithophores, microscopic algae from a world where ice sheets have advanced and retreated. In this dark graveyard of ancient plankton, you glimpse epochs of climate change recorded in sediment layers beyond human history. As you collect core samples, you realize that the Gulf of Mexico's trenches are mapped more thoroughly than this remote rift. Here, kilometers from land and high-traffic routes, no submarine cable has ever lain, no dredge ever scratched. The chance of capturing a whale fall or a landslide deposit is pure luck. Tomorrow, algorithms will parse your sediment cores for isotopic ratios, reconstructing monsoon cycles and plate collision events that shaped mountain ranges long since eroded. You wonder how many such records lie undiscovered in other trenches around the planet. Back on deck, scientists pore over their rove's high-definition footage. An image flickers of an anemone perched on a basalt ledge, its tentacles radiating in slow sync, each tentacle tipped with photophores. You recall that these black anemones produce a near-red luminescence invisible to most fish, an adaptation honed by millions of years in perpetual night. And yet, in a mere few hours, you have become part of an expedition to their realm for the first time. Later, the ship moves on to a mid-Pacific rise, where the ridge's axis has never been surveyed at high resolution. Long-range sonar painted it as a smooth line, but geophysicists suspect hidden transform valleys and seamount clusters. You deploy an AUV, Aqua Explorer, programmed to fly at 300 meters above the seafloor, pinging multi-beam echo sounders in dense swaths. As the vehicle plunges into its dive, you watch a folding map unfold on the screen's thousands of contiguous pings, building a grid of height values never charted before. In the control lab, the bathymetric map slowly fills with undulations, a series of parallel ridges offset by faults, now revealed in crisp detail. One segment looks anomalous, a bowl-shaped depression, 5 kilometers across and a kilometer deep, lying astride the ridge. Could it be the site of a large submarine landslide from a flanked collapse? Or perhaps an extinct caldera from a massive eruption that remade this section of crust? Over the next few days, the AUV will return with high-resolution video, sediment samples, and temperature profiles to probe the mystery. Meanwhile, the ship's beam trawls for water chemistry-dissolved methane, hydrogen sulfide, and metal concentrations. Where plumes bubble from the seafloor, you may have discovered a cold seep, an oasis of chemosynthetic life sustained by hydrocarbons leaking from deep sediments. In waters too deep for sunlight, these seep communities mirror their hotter vent cousins, creating geosynthesis hotspots in unexpected places along transform faults. Each new plume is a clue to unseen hydrocarbon reservoirs and microbial ecosystems unclassified by science. At another location, instruments detect microseismic tremors, low-magnitude quakes that rattle the hydrophones. They emanate from a previously unknown fracture zone, a left lateral fault offsetting the ridge by dozens of kilometers. Such transform faults host unique geochemistry, fluids that seep through fractured crust, carrying relics of Earth's ancient mantle to the abyss. Sampling these fluids could reveal novel extremophile microbes that thrive at 500 atmospheres and feed on iron-rich springs. In the lab, Geneticists hope to find enzymes that withstand pressure and heat, biotools for industrial processes on the surface. You realize that every plunge into these uncharted trenches and ridges rewrites the planet's biography. The rocks themselves, collected by the ROV's arms, will reveal igneous cycles, the timing of eruptions recorded in mineral grain compositions, the mixing of magmas at depth. Paleomagnetic studies will align each sample with a reversal of Earth's magnetic field, dating the seafloor layer and allowing you to reconstruct the propagation of the ridge axis over millions of years. Each core of basalt and pelagic clay is a page in Earth's autobiography, waiting to be deciphered. In the deepest trenches, you sometimes find microfossils of benthic foraminifera mineral shells less than a millimeter across, yet each preserving a climate story. Oxygen isotope ratios in their calcite tests record glacial maxima and interglacial warmth. Sediment drifts reveal turbidity currents, underwater avalanches that carry sediments from continental shelves into abyssal basins, an archive of ice age sea level changes and monsoon cycles tens of thousands of years old. As the expedition draws to a close, you realize that uncharted trenches and ridges constitute the final frontier of Earth science. On land, we have dwarfed mountains, despoiled forests, and splintered continents. In the sky, we have mapped every star. Yet beneath the waves lies a world unmapped at human scale. In those shadowed valleys and volcanic ridges, life persists in forms we have yet to classify. Archaic ecosystems march to chemosynthetic rhythms, and the rocks record epochs that predate any human record. Tomorrow, the ROV will dive one last time into a trench where the cables feeding its cameras have never been tested before. It will send back flickering images of an alien world, sponges in swirling clouds, amphipods dancing in living storms, shrimp that glow like blue embers. It will clamber over black smokers fractal etched in mineral crusts, and graze fields of bacterial mats that shimmer without sunlight. When it returns, the samples and footage will spark new hypotheses, new expeditions, new questions. Back on deck, you watch the sun set across the empty sea. The horizon is unbroken, as if nothing lies beneath but water. Yet you know how far beyond that line the unknown continues, trenches thousands of meters deep, ridges stretching for thousands of kilometers, uncharted worlds older than recorded time. In the hush of twilight, the ocean reminds you of its depths, a realm where no human has gone, where pressure crushes, where darkness reigns, and where secrets lie patiently, awaiting the brave or the curious to uncover them. As you drift into night, let that thought echo in your mind. The Earth as last frontier is not on some distant planet, but right here beneath the waves, in uncharted trenches and ridges, holding the oldest stories the planet has ever known. You stand on the deck at dawn, the sea a silver sheet stretching to an unseen horizon. The sky is pale with half-light, and every breath tastes of salt and promise. Below you, the water hides more than 2/3 of the planet's surface, an expanse so vast that even our most far-reaching vessels have surveyed only its shallowest slopes. The ocean's surface seems familiar, the cradle of sunset sails and shoreline festivals, but every gentle ripple conceals worlds so deep and remote that light and human voices never reach them. In that quiet vastness lies a mystery our minds strain to fathom. Imagine the first sailors who drifted beyond sight of land and realized that the sea could devour landmarks and erase paths. They charted coastlines, named islands, and followed seasons by the stars, yet the ocean still kept its depth secret. Centuries later, we hover in hovering drones and orbiting satellites, mapping temperature and currents, but the true contours of the abyss remain ghost-shaped on our charts, rough sketches of canyons and ridges, drawn by echo sounders too few and far between. For every trench we assign a depth, a dozen others lie untouched, their floors unvisited by steel or glass sears. Beneath the surface, darkness falls at a few hundred meters sooner than you might believe. In that eternal twilight, creatures gleam and sail in phosphorescent ballet, carrying their own light in patterns we only partly understand. Here, where sunlight never penetrates, geosynthesis creates oases of life on volcanic chimney stacks and methane seeps. Yet in countless miles of flat sediment, microbial worlds churn unknown, their DNA carrying secrets of evolution, of life springs that stirred long before our species drew breath. Every drop of deep water holds genetic code for feats of resilience we have yet to comprehend. Technology has opened windows to the deep, from remote-operated vehicles scanning mid-ocean ridges to autonomous gliders tracing currents in the polar seas. We have glimpsed hydrothermal vents alive with giant tube worms, and we have plumbed shadowed canyons where faint bloops and whistles echo like the planet itself singing. Yet these triumphs feel like peering through a keyhole at a cathedral. The cathedral's vast nave of mud plains, submarine mountains, and hidden trenches extends beyond our sight. In the hydrophone's recordings, we hear our own questions waiting to be answered. Even the canyons we map yield surprises. A rupture in the basalt might reveal a new vent field where black smoker chimneys belch superheated plumes, forming mineral sculptures in utter blackness. Or a feeding frenzy around a whaleless carcass sinking to the abyss might host species we have never named, their bodies adapted to pressure that would flinch a diver's bones. Each inch of seafloor we sample brings up chemicals and microbes that challenge our concepts of life's boundaries. And yet that inch represents only a pinpoint in a realm hundreds of miles across and miles deep. Our cultural stories mirror the ocean's mysteries. Myths of sunken kingdoms, of Atlantis and Ys, persist because the sea's depths have always felt beyond human claim. We dream of lost civilizations and sunken temples, just as we imagine strange beasts in the dark. Modern explorers fantasize about discovering a submarine forest alive with coral that glows in ultraviolet patterns, or a trench harboring an ecosystem spawned entirely apart from the surface world. Whether these visions prove literal or fanciful, they speak to a human need to believe that wonder still awaits beyond the known. Philosophically, the ocean's hidden realms remind us of our own limits. We measure time in tides and navigate by GPS, yet we cannot stand on the abyssal plain or hear the secret song of the midnight squid without a suit of steel. We build vessels to shield us from pressure thousands of times greater than our own. Yet even these vehicles scratch only a fraction of the surface. The ocean humbles us. It reminds us that mastery is often illusion, and that respect must flow from curiosity, not conquest. The future promises new tools, fiber optic cables stretching across trenches, fleets of battery-powered autonomous explorers, submersibles with transparent domes granting panoramic views of black water worlds. Artificial intelligence will sift through terabytes of video for new species. Genetic samplers will unspool the code of unknown organisms. Still, each advance blurs our understanding with new layers of complexity. As we resolve one question, what lives here? We uncover 5 more. How did they evolve? How do they communicate? How do they weather change? Even climate change and human impact drive home the ocean's mysteries. Acidification shifts chemistry in ways we can model only roughly, yet we cannot predict how deep-sea corals or chemosynthetic worms will respond. Plastic pollutants drift into trenches, but we lack data on how microplastics alter sediment ecosystems. Noise from shipping and seismic surveys permeates mid-water layers, yet we scarcely know how that alters whale songs or squid mating dances. Each ripple of change strains hidden bonds we have not charted. To dive into the ocean's depths is a leap of faith in human ingenuity, but also a recognition of humility. We reach for the dark not to tame it, but to learn from it about resilience, adaptation, and the fragility of systems far removed from our everyday world. In those vast arenas of silence, life clings to the smallest particles of energy, forging ecosystems that may hold keys to medicines, to biotechnologies, to survival strategies under extremes that echo other worlds' ice-covered moons or distant exoplanets. As your thought drifts back to surface life, consider how the ocean's hidden chapters mirror your own interior cosmos. Beneath the veneer of your daily routines lies an unseen world of emotions, memories, and potentials that you only glimpse when stillness descends. The ocean's depths invite introspection. Just as we strive to map the abyss, so we map our inner currents, hoping to understand what lies beneath our conscious shores. Both journeys require patience, respect, and the willingness to accept that some mysteries may endure. Tonight, as waves tear at the shore and moonlight ripples across the flats, let the ocean's endless mystery lull you to rest. Imagine uncharted trenches yawning beneath your feet, ridges rising in silent majesty, and creatures of phosphorescent grace drifting in perpetual midnight. Know that just beyond our reach lie realms that will outlast our lifetimes, beckoning future generations to explore, to dream, and to wonder. The ocean's secrets may never fully yield, but in the attempt to unravel them, we discover both the world's hidden beauty and the depths of our own capacity for awe. Conclusion. As the final light fades beneath the waves, we return to the surface with hearts full of wonder and minds awash in the ocean of secrets. We have drifted through sunlit shallows alive with dancing plankton, hovered in the dim twilight where bioluminescent lanternfish rise and fall in silent migration, and descended into abyssal plains so vast and flat they seem to stretch beyond eternity. We have glimpsed hydrothermal vents sculpting chimneys of iron and sulfur, whale carcasses nourishing entire realms of life, and trenches deeper than Everest is tall realms no human has yet explored. In every layer of water, life adapts with ingenuity that humbles our own innovations. Creatures bearing living lanterns stalk the dark. Colossal squid patrol ghostly canyons. Giant isopods scuttle over ancient mud, and microbes thrive on chemicals the sun never touched. These worlds remind us that our planet is more stranger, more alive, and more fragile than we often remember. They call us to listen to the crack of moving ice, the whisper of tectonic plates, the haunting songs of whales, and the ghostly bloops of unseen forces. As we close this journey, we carry forward both knowledge and awe. The ocean remains our greatest mystery, a living archive of Earth's history and a refuge of untold possibility. Its currents shape climate, its depths store carbon, its creatures inspire medicine and technology. Yet so much still lies hidden under pressure and darkness. Let this voyage inspire a promise: to explore with humility, to protect with purpose, and to honor the ocean's endless mystery. For in guarding the deep, we preserve a world older than history and richer than myth, a world that teaches us the true meaning of discovery and the silent power of wonder.